Hello everyone and good afternoon. I hope that all of you are having a fantastic Friday so far. The last 2 hours of the Friday are about to start, and today we are dealing with the topic of laser beam shaping, perhaps one of the most important topics for the laser community as of these days. I would like to first of all thank all of you for joining us, the EPIC team, on this adventure. Industry 4.0 is increasingly dependent on robots for high-speed, high-strength automated welding. The EPIC online meeting on Friday 19th will explore the state-of-the-art in laser beam welding. This is a topic that fascinates me. I even tried this myself. Heat is required to fuse metals. In laser beam welding, we use heat. An extremely powerful laser beam strikes on the metal and melts it. But there are still many challenges. For example, the use of the right beam shape for each material, the smooth welding of different materials with different cooling rates, stability, maintenance cost. So let's bring the entire supply chain on both key segments for laser welding, automotive and metallurgic industries, and let's understand what demands they have from the supply chain of photonics, from fiber to optics, from ruby lasers to jack lasers. It is all about making business while addressing challenges. This is a very important sector for photonics. I am delighted that the market leader Trumpf will be there. How will collaboration between manufacturers of lasers and beam delivery systems grow the market? Sign up to participate in Zoom or follow us live in YouTube. Be laser focused on the discussion on Friday, June 19th at 3 p.m. Central European Time. And it is Friday, it is 3 p.m. Central European Time, and here it is in front of us, the full supply chain on laser beam welding. It's a fantastic day for me, for Francesca, and for Antonio, because as you may know, lasers fascinate us, and this is incredible to have this meeting today. I just want to tell you a couple of things that are very, very interesting for many of you, especially if it is the first online technology meeting that you are joining. The first one is that the first one is, let me just close this, sorry. First one is the number 30 of the EPIC online technology meeting. So far we started on the 1st of April with femtosecond lasers, with the key femtosecond laser companies, and we've been covering every topic. The challenge was to have the key companies in the industrial sector and understanding what they needed from each other. And we are receiving such amount of great feedback from the industry, such amount, not only great feedback, but also interest in joining us in this adventure. We are almost now reaching the 600 members. Actually, it's 571. I would like to welcome the quantum dots that we are receiving now from Poland, from Wrocław University Q&A Technology. Thank you for joining EPIC. And also would like to tell you that in putting these meetings together, 39 technology meetings, there is a lot of work, really a lot of work. Francesca, Antonio, and I have the luck of being part of a dream team of people who are working desperately day and night from Monday to Sunday to bring these supply chains every 2 days. You understand, there are organizations that organize 10 meetings per year. We're organizing 39 meetings in something like 12 weeks. Totally crazy, but we are crazy. I also would like to tell you that EPIC, of course, we do organize events, present meetings. Some of our meetings are truly epic. Networking meetings as well, but most important, we give you access to the network, and this is very important for us. If you want to get in touch with any person from the EPIC industry, please tell us. We are more than happy to make an introduction. We are also raising capital for many of our members. If you are looking for either investing in startup, or you are looking for growing your market or looking for money for a particular challenge in your supply chain, please let us know. We're in contact with 80 investors worldwide, and we don't get commission. We just love helping the industry. Also, we are helping the people finding a job in photonics because we love working in photonics. We have actively scouted the job openings of our 571 members, and we have posted all of them in the website jobsinphotonics.com. So if anybody is looking for a new position in the YouTube universe watching this channel, go to jobsinphotonics.com. And also would like to remind that all of you, members of EPIC, you have access to a long list of market reports, actually 17,000 market view graphs, charts that are all available for you. I think it's good to highlight one of them today. Let's highlight the report of the day. Francesca, what is the report of the day?
Thank you, Jose. Well, of course, the report of the day is about lasers, right? So our worldwide market for lasers report from Strategies Unlimited. So it's really, we have here just a graph from that, but of course, our member can really enjoy the full, basically a book about a lot of, and having a lot of information about the market all worldwide. So not only Europe, but also in Asia, in US and so on. And what we highlight here is a bit two things that we maybe mentioned. So the tools and also an example of market. So laser welding tools, we see there is this old fight between CO2 lasers and thin disc lasers. So CO2 was the traditional one, thin disc lasers then emerged a bit later, but now we really hear always more talking about fiber lasers and even direct diode lasers. So here in the room, I know you don't know yet on YouTube, but I know there are many people that will have a lot of experience about this, and so we will talk for sure about this. And then I reported just one example, the car industry. So auto industry is really important reference also for laser beam welding. And it's not only because it's a huge market in general, of course, so a lot of money is involved in this, but also there are challenges for welding because in cars you have these curved 3D objects for the bodies of the car, and so that's a kind of challenge for some machines. And then of course there is the present and the close future, that is electric and hybrid cars. They need batteries, and that is also a very important topic for welding and laser beam welding. So we will hear about this for sure later on. And then remote welding, we want to be fast, right? Auto industry is also a sector that wants to be, as many others, fast. So remote welding will be also a thing we will hear today, and you can find in the market. So if you join EPIC, you will see what you get, and EPIC members already, please use them.
Thank you very much, Francesca. That was fast as ultra fast as the laser beam welding we're going to talk today. I also would like to remind all of you that we are totally crazy at EPIC and we do crazy things. The craziest perhaps what we are doing next week on Wednesday. We're going to be 24 hours in a row talking about photonics. Actually, I'm going to be sharing 24 hours in a row, a conference with 72 speakers worldwide. And I would like to acknowledge, of course, all of you who are sending me toys, caps. Please keep doing so. I'm going to be, of course, caffeinated and hydrated during those 24 hours. And that's it. Let's speak about laser beam welding. First of all, I would like to thank our sponsors today. First, the laser optics, the IBS coatings from OPTOMAN, all the way from Lithuania. Those laser optics that are actually the best when it comes to high power and high fluence and ultra fast pulses. And also would like to thank VIGO Systems, all the way from Wrocław, from Warsaw in Poland. They manufacture the mid-infrared materials, all those mid-infrared detectors that we love in the industry, but the material is getting so good that now they actually can even make lasers in the mid-infrared. Actually, 2 weeks ago, they made their first ever VCSEL. So congratulations on that amazing achievement. And this is what I wanted to tell you, because now I want Francesca to tell us what is in the menu today. Francesca.
Thank you very much. So there we are. So now we had a little bit of a glimpse of who will be the speaker today. But if we move to the next slide, you will really see the amazing ecosystem that is present here in the room. So as I mentioned before, we really have a lot of experts. And of course, if we talk about the topic in photonics like laser beam welding today, we first want to address the needs of our end users. So today, I'm really happy that we will have here for the first time, I guess, in EPIC at all, Comau. So as I mentioned before, car batteries will be a topic, so that is good that we will hear about it from our speaker today. And then, of course, other applications for laser beam welding are in consumer electronics. So Huawei is definitely a good speaker about it, and is a better representative. Then we have other kind of batteries, so the lithium-ion batteries in general that are also important for Hitachi. So that's why it's also a big topic. And then photonics assembly for fix. So these are our end users, but of course, the end users get some system from someone. And so an important speakers today will come from industrial workstations. So Lava X, thank you very much for being here. This is the first, I guess, meeting as well for you in EPIC. And then AAE is also very important to mount industrial system. Then laser system engineering experts are also here. So we have the power supply for PBF, but also all the expertises from PLX, Glenn Dimplex Deutschland, and also AMS Technologies. So we will hear a lot about this sector also today. Then laser heads. So the laser doesn't go in the system by himself. He has to be mounted on a laser head. So we are also here really proud to have Precitec speaking today. So thank you for joining us. And then finally, I mean, the main core of, we have really many EPIC members in these fields, in industrial laser manufacturers. And here we are really happy today to welcome also old friends, so laser, so EPIC members, but also potential new members or really old friends of EPIC. So really pleased to welcome later on Civan on Eyal and Trumpf, and Trumpf and Civan will speak together with TeraXion. So we will have 3 major speakers, but also IPG Photonics, not EPIC member, but still a very important player. So we're really happy to have you here. And then also Laserline and Nuburu. So we will have really a lot of the complete overview from the industrial laser manufacturers. Then, as we heard before, laser diodes, we cannot forget them. So Monochrome is also here today. So thank you for joining us. And we will have all really the developments going on. But of course, we don't want to talk only about the lasers of today. We also want to talk about the laser of tomorrow. So that's why it's really important to have also laser welding R&D members that are really here today. So thanks a lot from Fraunhofer IWS to join us. So we're really expert in laser welding. Amen. So Pablo, for the first time, I meet you here in person, and we will have a lot to do together soon with the European funded initiative. So welcome also today. And then we have Ford and NCLA also as expert in the future R&D for lasers. Then, of course, safety is important. We definitely talk about high power laser today. So thanks a lot for Univet to be here. So for laser eye safety is really important. And then, of course, the system doesn't run if we don't have a nice system, a nice process and quality monitoring, so that everything really runs smooth. So here we have also a lot of representatives today. So I'm really pleased to welcome Les Müller, that is for the first time, I guess, also joining an EPIC meeting. And then we have some veterans, of course, of EPIC as also sponsor, VIGO Systems, thank you, Newer Infrared Technologies, MKS Ophir, so of course, let's not forget. And then Laser Optical Engineering Ltd, thank you for being here. And let's not forget, very important, we have a European funded project called Multiple that is dealing with the hyperspectral imaging based quality monitoring and process monitoring systems. So it's really important that we don't forget that this is also very good potential market for this project. So laser beam welding, definitely. Then the monitoring doesn't work if you cannot build it with some very nice optics. And we have here really a lot of systems integrators and system manufacturers here in the room. So we start with laser beam delivery, very important, OPI Photonics, welcome. Laser beam shaping, Kylabs, and of course components from Excelitas. And the fibers, let's not forget them, we might need them as well. So IX Blue Photonics, welcome also for joining us today. And coatings. As I said, really high power. So we have our OPTOMAN also we just said before, sponsoring the meeting. And then Actor and Optic Balser. So thank you for being here. Coatings, filters is really an important part. Then the service has to be delivered. And so that's why we have Amen and Pulsate together. So this is the project that Pablo will talk about later on. And then to not forget, optical design is really important, otherwise we don't get to the real device. So VPI Photonics, welcome. And then distributors and consultants. So thanks a lot, Optoprim, to be here, and also IHB Consulting. And I guess I'm done, and we can go to the important people, right, Jose?
Thank you very much, Francesca. I would like to clarify that for any of those who are saying, oh, they forgot my logo, we never forget any logo. We never forget any of our 571 friends. This slide represents only the companies who register for the meeting today. I would like to remind that this meeting is broadcasted in YouTube. So hello, YouTubers. We would like to remind you that if you want to get in touch with any of the participants today or at any time when you're watching this, all you have to do is send me an email, jose.pozo@epic-asoc.com. The same goes for the people in the Zoom channel. If you want to get in touch with each other, of course, you are free to use the private chat. But if you want to connect, you can always send me an email. I'll be more than happy to connect you with whoever could be your potential partner, supplier, and customer, because at the end of the day, this is what it's all about. And now it's going to get the ball rolling. Now it's when we start, and I would like to ask Francesca. Francesca, who is the first speaker today?
Today. So we have to go to the way to Germany. I guess we have a lot of Germans today here. So yeah, me too. I'm in Germany as well. So Matthias Beranek is our first speaker. So from Trumpf, I am really welcome and thank you for being here. And please, the floor is yours.
All right, thank you very much. Good afternoon to everybody. I've already seen a lot of familiar faces. And also I would like to greet the attendees out there. I've learned that I only got like 6 minutes or something like that, so it will be very quick. I just will show you what we are mainly concerned with talking about laser welding these days. As you can imagine, and a lot of you know that, there's a lot of stuff going on in e-mobility. So you can see here in the green boxes what are the main application fields, like power electronics, battery cell and module assembly, the battery container, which is actually a car body part. We have a lot to do with hairpin e-drives and also the rest of the drivetrain components. And also we are looking into fuel cells at the moment. So there's pretty much from everything. What I think that there is a huge shift from what we've seen in the past, like steel and aluminum welding, to mainly copper welding. So this is something we're looking particular into. And for that, we have elaborated a whole new laser lineup, which are the green lasers based on the disk platform by frequency doubling. Reason for that being, as you can see here, absorption of copper in that wavelength green is 40%, so it's much higher than infrared. And this gives you much better handling of that welding applications. And we have also found that we have to have a very high beam quality, as shown in the middle. So you can see different welding depths where we are very fast in welding, but this is only achievable having that high beam quality, which we will maintain from the disk platform. And also what speaks for the high beam quality is the system technology, which is on the right side. So we've tested everything in visible wavelengths, meaning we also have a blue laser in Trumpf, but that turned out that we cannot use what we want to use, which is scanning optics for our fast processing. So high beam quality and green laser light enables and improves the copper welding applications. We talk about comparably shallow welding depths, like in this case 0.35 millimeters in bead on plate copper, but with a very extreme stability of the welding depth. And this cannot be achieved with infrared, but only with the green one. And this is something very new. Also, we see the classical battery cell applications like foil stacks will become feasible with those green lasers, as well as the mixed metals, so aluminum with copper in that case, where we just want to have so extreme stable welding depths in that case in order to maintain that. Another major breakthrough technology is actually multi-spot laser welding. In our case, we call it bright line weld. That is the Trumpf name, and we've also originated that technology up to 16 kilowatt. As you can see, we will use a 2-in-1 fiber guide. That practically means you will be using 2 spot sizes at the same time with a certain power distribution at different sizes. The main effects of that being most notably a stabilization of the welding process, which means the keyhole dynamics, and so on. And this results typically for everybody to see in a significant speed reduction, minimization. It is suitable for all materials we see in e-mobility and, of course, other industries. In steel, we will get a high speed gain, which means exceeding 20 meter per minute, 30 meter per minute welding speeds. This is extreme and crazy what's going on here, as well as having a higher efficiency, meaning power can be reduced to achieve the same welding depth. In copper, we have the low and high speed ability, especially low-speed welding for higher penetrations. Not having a special fiber guide is difficult with copper. Now this has been overcome. And also we will see smooth weld seams, as copper is a little prone to blowouts and rough surface. And that's what it is. So this is also improved. And in aluminum, we've seen that we can have crack-free weldings for the 6000 alloy, which a lot of people are afraid from. So this also improves that. So, and this is just 3 examples what we do with Brightline. So in comparison to the green laser, where we have like heat conduction modes in welding, Brightline, especially in combination with copper, is thought for deep penetration, higher penetrations. On the right side, maybe one of the most extreme examples is the penetration of over 8 millimeters into copper. And this is what we can realize here with the multi-spot Brightline weld technology in that case. And these are 2 things, mainly as you can see in the copper area, what we are working with at the moment. There is a ton of applications coming up from that. And there's a bright future for all of the laser technology, actually. One thing maybe regarding the community, and this is my last sentence here, is that for most of those applications, we have to bring together multiple things, one of which is, of course, the beam source, the fiber guide, but also application know-how and sensor technology, including data handling, interpretation, making the processes smarter. And this is where we have to work together more closely in the future. And this is the path, what we will be seeing. So thank you very much. I kept it very briefly. And that's pretty much it from my side. Thank you.
Thank you very much, Matthias, for your contribution. So it's really clear you didn't have, I mean, you know, the typical EPIC questions, what can you do for them? What can they do for you? But you already mentioned basically the full value chain could help you. So that's already like in one sentence, the meaning of EPIC. So the full value chain is here. So maybe someone of these people belonging to the value chain wants to comment or ask questions to Matthias. What is it? So now they are all shy, but then I know Rodrigo is writing something because Rodrigo is our monitoring system guy. So welcome, Rodrigo. Can you we start with you, maybe to introduce yourself and you say how maybe you can help Matthias. I guess you have a couple of things to tell him.
Yeah, thank you. For those that don't know about us, we are a manufacturer of high-speed infrared cameras. We are a Spanish company. And we have cameras that are introduced in the production line to monitor welding processes in real time and to assess the quality also. We have made many collaborations in the past with many companies, especially for welding of similar and dissimilar materials. And for example, with IMEN, we have made the integration of our camera together with a deep learning system that is capable to detect defects happen in real time. The system is trained to detect these defects and provides a quality assessment right after the process has been finished. Of course, trying to reduce the number of visual inspections and destructive testing afterwards. So we have a very good technology, high-speed infrared imaging. Things are different as soon as you move into the infrared rather than keeping observation with CMOS cameras in the visible range. Because we look at the thermal emission, and if you add that with a high-speed camera, then you can see the dynamics of the melt pool, which contains a lot of information about the quality of the process. So in this sense, Matthias, we can help you with our cameras to monitor the processes.
Sounds good. Thank you very much.
Very good, very good. So if the audience here keeps to be shy, maybe I give one last hint to Matthias, and then we talk maybe a bit later. Michelle, maybe from PLX, would like to tell what is PLX doing and what is your interest to be here, and maybe how you can help Trumpf and Matthias. You are muted, Michelle.
Hey, good day, everybody. So yeah, so PLX, we basically design and fabricate high precision optics. So I think with a lot of the meetings today, laser beam welding and laser solutions is pretty much what we do is redirect light in different ways, retroreflectors, monolithic, invariant structures. So I think we had done a presentation previously in one of the meetings. I think a lot of applications in laser systems would really work for you guys in terms of, you know, basically having invariant systems like you had basically to redirect your laser beams. You can have multiple different sources all combined into one system, and we can have all different sorts of mechanisms to rotate the beam and really deliver high-powered laser systems. We do stuff very with athermal design, so a lot of the and vibrations, and that's kind of what the core of what we do. So I think in that, working with the presentation you guys just had, something like that would be a great connection if you guys want to talk further.
Right.
So Matthias,
thanks.
I guess this is just the first 2 contacts you can get today, but I guess we can go on also later on. When Jose maybe want to say something?
Yes, of course. I was going to say things. Matthias, every year I see more and more companies developing laser optics. It looks like it's very easy to make a company to make laser optics. Every year I go to China and at the CIOE conference, now they have a huge hall, the same thing in Shanghai, more and more companies. Do you notice, especially in the high power sector, that you still have the challenges on laser optics covered, or is there any unmet needs for the companies in the room? I don't know if you heard me, Matthias.
I heard you, yes.
Yes. Let's talk about laser optics. Are there still challenges?
So at the moment, maybe one of the challenges we're having introducing those green lasers is actually, of course, we have to adapt what's in the optics, the lenses, the mirrors, and so on, according to the new wavelengths, especially at the high power density. So that's pretty special about that. And besides from that, we can see also that there might be a lot of demand for very high powers in infrared lasers. So we already talk about like going up to 20 kilowatt and more, especially for like cutting, also welding applications. And this is something which of course gives a lot of challenges to the optics in combination with a high brilliance, high brightness. And for that, I would expect a lot of movement in that, because the optics as we use it today, need to be improved in order to go with that specifications we're facing.
I'm very interested in there's a company that I really like, that is Laserline, and Markus is here with us today. Hello, how are you doing? I would like to learn from you. Do you have any challenges for the laser optics sector when it comes to the high power, high fluence beams?
Of course, it depends a little bit on what wavelengths we are talking. If we talk about the infrared wavelengths, actually our highest power is 45 kilowatt that we manufacture and deliver. And yes, we needed to review the classic optics for these power densities, that's clear. But if we talk about blue, actually we deliver 2 kilowatt systems. We're testing higher powers in the lab, and the coatings of these optics needs to be improved, like Matthias just said. But the general performance of the glasses is not the biggest challenge. Another challenge we of course have is the energy density is increasing and increasing, that's true.
You heard what he said, that the coatings have to be improved in other wavelengths. I'm looking at optics pulsars because I really like this company. Aren't you curious what Laserline just said, that the coatings needs to be improved?
I'm sorry?
Yes, we just heard from Markus from Laserline that when it comes to the 2 kilowatt power, the coatings, he said the coatings need to be improved. Are you curious? How do you see this market for optics pulsars?
Yeah, this is expression we have to improve the coating. We have to improve the coating technology to get much more higher LIDT, how we call it LIDT value. So it comes up The last year we focused only on 1064. And now it comes also for us in the challenge that we have to apply this for the blue and also for the green wavelengths. And we do this by improvement of the coating technology. Yes, of course, we work on that. This is a well-known field now, yes.
Back to Francesca, but now we have one of the interesting topics for discussion later. Francesca.
Yes, so now I guess we can go on. If there are no last questions last minute, we can go on with the agenda. So now it's time for Giovanni. So welcome, hello. Giovanni, CTO from Comau. So I guess we can give you the floor and we look forward to your talk.
Hello, everyone. Nice to meet you. I'm Giovanni. Can you see my screen? Okay, thank you, Francesca. Yes. So I'm responsible, let's say, in general of technologies in the electrification business unit, and more in general, I'm in charge of the laser processes of Comau. I'll give you some key figures about Comau. Comau is a company about more than 9,000 people, and as you can see, these are some of the numbers that can better explain where we are and who we are. Let's say the most of our business is in between EMEA region and North America, but we are growing a lot also in APAC region. For what concerns the people, as our company is made, first of all, about people and ideas, we are more than 90,000 people. And as you can see, we try to explain that we are getting younger and younger to get closer to the market that is changing, okay? We invested a lot in graduate people, and most of all, we invested a lot in project management as a key success factor in our business. Last but not least, we decided to explain that we have more than 200 people that are electrification specialists, as we are investing a lot in this new market that is about creation of value in the automotive industry, but more in general, also in the production and the distribution of energy. For what concerns the activities, we decided to share some numbers about the last 3 years that were very successful, as we have more than 250 projects, more than 20 new products launched, and we have more than 150 customers with our Comau technologies. This is a very simple screenshot about where we are in the world. We started everything in Italy. Our first job almost 50 years ago was in Russia, but then we spread it all over the world in order to manage our customers with the best possible global approach. For what concerns laser technology, we started working on it in 1985, so we have been one of the pioneers of laser technology. And let's say we worked a lot in the automotive industry, but we are trying to move forward in a more general approach. This is a very simple sketch about our offering. I decided to start from the very first one, that is the one about consultancy, as Comau is an automation system provider. So we are quite different with respect to Trumpf. We are not working with that level of dedication on laser and photonics, but more in general, we are working on system integration. And we decided, as you will see in the next slide, to invest as much as possible on verticalization. But I think that what makes, let's say, our differentiation is our ability to work together with the customer in the design for manufacturing area. Okay, these are sort of specific consultancy that only companies like Comau can provide. Of course, our greatest level of expertise come from our root, that are the body assembly, the machining, the powertrain assembly jobs. But as I said before, we are moving forward in the electrification market. We are winning several projects. Some of them are already completed about batteries and e-motors. But we're working a lot also in renewable energies. Okay, and this is making ourselves very proud of what we are doing, because we are trying to create a better world with better technologies. We are the biggest robot manufacturer in Italy. one of the most important also in Europe. But let's say one of the things that I wanted to share with you is that we're working a lot in human manufacturing environment. That means that we're investing not in technologies for providing 100% of automation, but we invest a lot in wearable robotics, collaborative robotics, in order to create processes where we can use the operator in order to upskill it, and in order to provide higher quality to the final process. Last but not least, we decided to create also an internal academy, because we believe a lot in what means creating value by passing competencies to the rest of the community. So we are having several programs and masters all over the world with several different academies. As I said before, we are trying since, let's say, in the last 3 years, we decided to verticalize as much as possible in all our markets. I'll give a brief overview about what we are doing in terms of photonics. In 2017, we launched our laser source, but in the last years, we decided to complete our product portfolio, of course, with our robots, but most important, with our welding heads. We're working a lot with some Polytechnic of Turin spin-off that are working on photonics in order to create custom heads for our processes. And what is making, let's say, the difference between Comau and other suppliers is the possibility to use our hybrid thermography for inline real-time quality monitoring. Last but not least, we have our own integrated big data platform that is called Ingrid to collect all the data that are coming from the process in order to grant to the customer the possibility to have real-time control over the process and a better maintenance for the complete line. This is a picture of our lab. We invested more than 3 million euros to create a laser lab for product validation for our customers. What we generally do is very, very simple. We do coupon for our customers in order to define the best weldability lobe, in order to understand which is the best possible scenario to grant the capability to our customers. Of course, not just by granting anymore the mechanical strength of the joint, but concentrating ourselves as much as possible also on the electrical performance of the joint. In order to do it in the best possible way, what we decided to do is to integrate our hybrid thermography that comes from a huge investment that we have done in the last year by opening our own software development center in Bari. We are working a lot together with the Polytechnic University of Bari in order to create a software house that is dedicating themselves to the creation of this new software that is permitting us to use artificial neural networks to analyze videos collected in real time by infrared cameras, so that we can understand without any kind, let's say, of disruptive test if the quality of the joint is good or not good, okay? By granting at the same time the possibility to have good quality in terms of mechanical performance, but also, as I said before, in terms of electrical performance. Thank you very much.
Thank you very much for a great presentation. I was actually already taking notes, a lot of notes for what you are gonna face now. This is your first ever EPIC meeting, but your colleagues already came to an EPIC meeting on laser welding and laser core photonics the last time, and it was really, truly epic. What you are gonna get now is the epic question. What can all these people do for you? And what can you do for them?
It's my time. So for sure, what is important for us is to enlarge our spectrum of solutions for our customers. So what our customers are expecting is to test new technology as fast as possible. What we deliver as Comau is, as I said before, the availability of our labs, where we, in a very fast way, can test and integrate new technologies in order to make coupons validation for our customers. On the other hand, what we expect is a huge cooperation level from our suppliers in order to create the best possible solution in the best cost-effective scenario for our customers.
Of course, and when I had the end user telling me this, I always ask the same question. You're making it very simple for me. It's a standard. The Santa Claus Christmas list, a challenge that you still don't get from the market. Challenge these people. They are here to listen to your challenge.
Yeah, for sure. What we are trying to understand is which is the amount of power that arrives on the joint in real time. What we are looking at is not just to grant what our customers and the electrical performance of the joint, but what we want to grant is also the performance in terms of aging of the joint. And in order to do it, we have to know in real time the exact amount of power that is going on the joint. Okay, that is not so easy, let's say, with the actual technology that we have at the moment.
Right,
what we are doing with the thermography is to do an indirect measurement in order to collect this information.
But that's because you don't have yet what my friend Gunther from Les Muller has, right, Gunther? Gunther, how can you help Giovanni from Comau?
Oh yeah, that depends on the application. So from my side, hello, Terry.
Car batteries.
Can you hear me?
Yes.
Yeah, okay, very nice. Yeah, it depends on the application. So what you're dealing especially is surface scanning using a topography. I'm not sure if I can help you, Giovanni, for this energy input into the weldings, but maybe we can talk about this in the private room.
Who can help Giovanni? Of course, I know that my friends from NIT Europe in Madrid can really help, and he already presented, and that's obviously one introduction that I'm going to have to do for you. In addition to the monitoring of the process, one thing that I'm always worried when it comes to laser beam welding in the automotive sector is really the long-term stability. So one thing that I would like to ask you is, with the current technology for laser beam welding, are there challenges in terms of lifetime or in terms of reliability of the process?
But let's say that what we do together with our customer is a capability analysis. That is something that we do before installing the line. So we ask the customer materials in order to check what happens to the process if we change some process parameters. For example, more or less power, let's say different type of filler material in case we use a filler material or everything else. Let's say that to grant a better product, or let's say process stability, we are investing a lot on software design. For example, we created a vision system for protective glass inspection, so that once we see that the protective glass is no longer clean, we change it. But we change it only when it's needed, okay, in order to save also, let's say, money and time.
How does it work to be a partner in R&D with Comau? Do you do all the R&D in-house, or are you looking sometimes to have some, let's try to weld these two materials at an R&D center?
No, we are quite open from this point of view. Let's say, as I said, we invested a lot and we have a very good cooperation with the Prima Industrie, as we developed our own laser sources together with them. So, as you know, by our history, we are very open. Consider that Comau means Consorzio Macchine Utensili, so it's a consortium of companies. So we're very open to this approach. On the other hand, if we can do something on our own, we prefer to use our technology, but not for money. We prefer to use our technology because in case we have to change something, in case we have to customize something to make the process more reliable, we want to have the possibility to do it with our hands in very short time. But if we don't have this technology, as you know, our DNA is the one of the system integrator. So we are very open to work together with our suppliers or partners to make innovation together.
Two things to tell you. The first one, well, there is a question, but I have to give the floor to somebody first. First, well, of course, ciao, Maurizio Gattiglio. I know you're watching this. I would like to say hello. The second thing is to ask Pablo. Pablo, you have something nice to offer Comau, right?
Well, in general, yes. We like very much to work together with integrators. it's not only us. I think all the laser centers and technology technology centers in Europe. I think we live in an area with excellent laser research facilities, and with excellent machine builders also that can work together in particular ways. I agree with Comau that their capabilities are impressive. I've seen their integration of lines that allow different variants of vehicles in a single geometrization structure. That's very amazing. What we offer is the ability in a single center to combine knowledge about materials and metallurgy, knowledge about basics of optics and optical design, knowledge about the monitoring and automation, and links. We are like a hub, and we will talk later about that, able to find the right answer and solution to certain aspects that normally are deal with in the integrators by patching, but there are some fantastic small companies providing solutions that we happen to work with.
Pablo, I've been to your laboratories. I've seen your Precitec laser heads, so beautiful, such a cool piece of equipment. And also I have seen the rest of the lasers, and also have seen how you actually help other companies as a workshop making a very high-end welding, or actually testing welding for the long-term reliability. So Giovanni, you need to go to see VIGO. It's a beautiful, beautiful city next to the sea, a great place to eat, and great place to have a potential partner in R&D. Markus has a question. Markus.
Yeah, it's not necessarily a question, just something possibly needless to say, but here is 2 companies making blue diode lasers, 1 company making green lasers. And obviously, Giovanni, you are very, very much invited to visit us and bring your applications for blue lasers, where we can help you in our applications lab. I mean, we have done several projects together with Comau and infrared. Very easy to go for blue. I mean, I can sell you a laser, that's not a problem, but you are very much invited to join us here as well. Same for our others, like Pablo, he also did some trials as far as I understand, but we can go on with that, no problem.
Yeah, indeed, as soon as this crazy time goes over, we are all going to travel, and we are all going to visit you, Markus, especially me. I'm going to go there and knock on your door because I'm really super excited.
Our lab is open. We have visitors here every day.
Oh, fantastic. You're going to have one in a couple of weeks. And I'm going to go now to one of my key companies when it comes to laser heads. I'm really happy to have Precitec here because I keep meeting them at conference and say, come on, come to the epic meetings. Markus, thank you very much for bringing the best laser heads in the world to this meeting. The floor and the attention of everyone is yours. I think we still have you muted. We want to hear you. Yes, I think you need to unmute yourself. Yes, at the bottom left, you had the,
okay,
there you go. Yes, perfect.
You understand me?
Oh. We hear you and we see you very clearly.
Okay, so I hope my presentation will be seen right now as well. Do you see the presentation?
It is coming, but it's not yet here.
Okay.
I think you have to go to the bottom of the screen, press the share screen green button, and then select which window you want to share.
So let's try that. You see me?
Not yet. We may be experiencing some problems. Let's try the following. Go to the bottom of the Zoom window. Do you see the arrow up that is green? There you go. It's coming. It's here. It's here. There.
Okay.
Yes. Go to presentation mode, and then you know how to do perfectly. And the floor is yours.
Okay. Thank you very much for so as you may see, it's my first Zoom conference. We are typically using different tools nowadays, but nevertheless, okay, let's start with the topic of this afternoon, which I want to present to you is some success stories in laser welding and to show what is important. And important is the combination of sensor technology in combination with processing optics. Just a few words about Precitec in 2020 or 2019, more or less. You see that we have nowadays 610 people working for Precitec worldwide. So this is quite impressive. If I remember the days 25 years ago when I started here, it's completely different to these days. And yes, we have a quite respectable turnover and a growth like everybody. Let's see what happens in 2020, and the numbers for this year will be different. Nevertheless, this is what we are working on. I want not to talk too much on that because it's quite definitely more easy for you to go on our website and to see the divisions Precitec is active. Just to let you know that we are two companies in Germany. One in the region of Karlsruhe, which is doing the laser materials processing stuff, and the other one which is in Frankfurt, and which is doing measurement stuff and medical technologies. And so what I do is to bring both expertises together. So let's start also with a very important subject these days, which is e-mobility. We as laser people, we as people in the photonics industry, we are quite happy to have that challenge nowadays, because we do not have to compete that much with existing technologies. We can design applications right from scratch with the laser as a tool, and with sensor technology to supervise, to control these processes. And you see, this is more or less the content of my talk. I want to go from the top to the bottom to bring a few ideas on laser processes in hairpin, in contacting, in busbar welding, packaging, and also body in white applications to you, where we already have running applications. You will see that not all the applications I'm allowed, for all the applications I'm allowed to tell you the customer behind, but in the end you will see a few of the customers at least which we are working on. So we think Precitec, we do have a solution for all these applications in e-mobility. So let's start with the topic of process monitoring. The devices, the tools we have developed over the years are highlighted in blue here. They are called Weldmaster, they are called IDM, LWM. These are the systems and the names we gave to the systems. And as for those who are familiar with laser processing and also familiar with process monitoring, they know that we divide the process region into in and post-process regions. So these are the areas where we can apply the sensor technologies to. Let's start with the LWM, laser welding monitor, all-time favorite, a rebirth more or less of that sensor technology. Just started a few years ago. We have a lot of applications running right now with the old-fashioned sensor technology based on photodiodes. Nevertheless, it's quite easy to retrofit existing welding applications, welding systems with this sensor technology. And we are the ones which more or less try to bring more than one sensor into these applications. So sensors which are covering different areas of the wavelength band in order to see more than just one possible failure, one possible error which can occur during the welding process. And just one application in battery contact welding, you see the laser welding monitor just mounted on a third-party scanner. And additionally, you have the camera port. So it's a possibility to also adapt any kind of camera, for example, NIT cameras, to these devices. So the application behind is in production since 2018. As I said, I cannot tell you the customer behind, but what is done here, for those who are familiar with battery contact welding, it's not that surprising that it's copper to aluminum or copper to stainless steel welding or aluminum to copper. You see application here, or the surface of the user interface, where you can see in real time the welding applications and the green or red indication of a good or bad process. So this is what we typically do. We make a picture of the application, a photo of the application, and directly show the customer which part of his process was good or which part was bad. Another application is bus bar welding. What you see here is more or less a little bit the underneath the surface of the laser welding monitor, where we have a lot of statistics, and you see here typically three typical problems which can occur in these applications. It's a gap between the sheets. It's a laser power drop, which can occur, for example, which was mentioned before, because of contaminated protection glasses, or a defocusing, which is happening because of misalignment of the part. And you see that different sensors, in that case temperature and back reflection sensors, can catch these errors, and they can catch these errors very dominantly, and can distinguish good from bad parts. Another application in busbar welding, when it comes to copper welding, you see one of the processing heads of Precitec here in combination with sensor technology. This is what we call scan welder. It's a 1D scanner. It will occur later on in a different application as well, but in case we can use our own processing heads, it's quite easy to adapt our own sensors, and it's quite easy to select the right mirrors, the right glasses. We also already talked about coating. Coating is very important, not only when it comes to different colors of the laser sources. It also is important when it comes to different sensor technologies, which use specific wavelength bands for their supervision. So that's why coating is a very, very important topic these days, also when it comes to monitoring devices. One of the monitoring devices which has to come in presentations I do actually is the use of OCT technology in laser applications. In Precitec, the sensor is called IDM, in-process depth meter. When we started with that technology, we thought maybe it's important for customers to know the penetration depth. What we see right now is that penetration depth is important, but not the most important thing you can do with OCT technology. Nevertheless, this is what I will show here are just a few examples of penetration depth measurement. So again, busbar welding, again, the scan welder of Precitec in combination with the OCT sensor, and device which we called keyhole finder. This is a new device which comes with the OCT system to align the sensor spot, the measuring spot. You have to be aware of the fact that we are talking about a diameter of the measuring beam of about 50 to 70 micrometer. And the alignment of that measuring beam is very, very important. That's why we need some devices to help the customer to align that measuring beam to the right position. And you see here in the busbar welding, we can easily do some penetration depth welding. Even if the keyhole is very small, even if the penetration depth is very small, we can adapt that OCT technology to these applications. You see here aluminum to aluminum or copper to copper. So what is very important to know is that the process emissions do not disturb the measurement. And we can measure penetration depth or topography or whatever you use the OCT sensor for in micrometer resolution. Now it comes to the last device, what we call Weltmaster. This is a camera device which is looking right coaxially to the laser beam. What you see here in the video is the view on the directly into the interaction zone, which comes with two projected laser lines which do seam tracking or weld quality topography measurement. This all is the Weltmaster system, which you see here in a sketch. So again, a Precitec own built the device with a 1D scanner. And what we can do easily with that 1D scanner is to oscillate the laser beam. For those who also are a little bit familiar with laser welding know that some of the applications do need a stable keyhole, and you can stabilize keyhole by very fast oscillation of the laser beam. And also, if you do lab welding, what is displayed here, it sometimes helps if the gap is varying, that you are able to oscillate the laser beam in order to bring some material from the top sheet to the bottom sheet. And this all is possible with the Weltmaster scan and track with all the inspection and monitoring systems. And the customer behind is Audi. We have one application running since 2017 where we use that device in e-mobility to close the battery cell module, which is mounted underneath the Audi e-tron. You see here in the application, it's a 5,000 to 6,000 aluminum, and that requires some oscillation of the laser beam and some controlled process power input. And that's why we also do not only oscillate the laser beam, we also control the laser power. This is what we do since 2014, also on the Audi A8 doors. So this is also 6,000 series, and by oscillation of the laser beam, we can also do some pore-free and crack-free welding. And what is very important, there is no additional material, no filler wire needed in that application. So this is the customer benefits which comes with that application, which was presented several times by Mr. Weberpals from Audi, with the use of the oscillation and with getting rid of filler wire. There is a heat reduction of 47%. The reduction of the investment cost is quite remarkable. Running costs can be saved, and there's a lot of time saving. So, and additionally, by using the inline control of the Weltmaster system, there's no additional station needed for a quality check. So just close my presentation to some messages for you, hopefully to take away and to remember more than this afternoon, longer than this afternoon. So we see that there is a high diversity in laser concepts, and these application-specific applications ask for specific laser usage and ask for specific processing components. And we as Precitec, we see that modular design of that turnkey systems is the solution which we can provide to customers. As we are able to fully implement sensor technology for all the important region, pre, in, and post-process regions, we can help customers to really bring very high quality standards in their application, which also meet Industry 4.0 requirements. And we still see our company as a reliable and curious partner, providing these the required system technology at the end of the optical fiber. So any laser manufacturing company is happy to work with Precitec components. So let's thank for EPIC to having me to do some presentation this afternoon, and I'm open for questions. Thank you very much.
Thank you very much, Markus, for your talk. So I see you didn't have the Christmas list like or usually Jose says, but you had all across your slides, all your wishes. So is it correct? You said already at the end, the laser manufacturers could work for you, but also coatings are important for low and high power. So also for low power, probably for the monitoring, also systems to guide the beam. Is it all correct, right, Markus?
Yes, correct.
Very good. So is there someone in the room, because here we have many representatives who want to talk about a specific wish of Markus? Otherwise I pick you, because I know that, for example, Alexander for ACM and ACTAR for coatings, maybe he wants to introduce himself and say the interest to be here in this meeting.
Yes, hello, thank you, Francesca, for the opportunity to speak shortly. So we are specialized in very black absorbing coatings for light, also for laser power. We know Precitec is a customer already, but maybe it's important to know that our coatings do not only absorb laser power, very high laser powers, but are also good to absorb light in the measuring path of the system, to suppress tri-light in this paths, or to get additional power out of the path. So this is what we are actually doing in the laser world.
Very good. So if you know each other already, nothing new, but maybe others heard what is possible to do also with Alexander and with ACM. Very good. So Antonio, I guess you have a question? Yes.
Let's say I'm really impressed about the improvement of all the laser welding technologies. And I am feeling that now the core of the process is really moving on the processing head, and processing head is become very, very complex. So I'm curious to ask to Markus, maybe now you are in a position to ask to the laser manufacturer requirements and so on, and not vice versa. You are not receiving a laser and then you have to adapt your technology, but you could ask maybe special beam shaping or even direct control in the switch on, switch off timing of the laser.
As we just provide the processing heads, we definitely need to work together with the manufacturers of the laser sources. Yes, you're right. We are in a situation today that we just more or less need to know the beam quality and the color of the laser, and the rest more or less is in our hands. And this is a quite a good situation. Nevertheless, we are also in a situation where we see that those who build laser sources also build their own processing heads. So it's we still need to find a unique selling position in between all the sensor providers and all the laser providers. And what we see is for Precitec as unique selling position is that we are the experts in combining the right sensor to the right processing head. And as you see, for example, when it comes to applications with 2D scanners, we are now in a situation that we don't have our own scanner. So in that applications, we just need to work together with the manufacturers of scanner systems. So as a lot of applications in laser welding applications are now using scanners, 2D or 3D scanners. So fixed optics may maybe not be the ultimate solution.
Markus, cooling, these kind of things, these laser heads, the cooling is a big challenge. Are there still challenges to keep the laser heads at the right temperature, operating at the right temperature?
Yeah, we are luckily in a situation that the bulk material of the glass which is coated and which is used in the laser heads, it's getting better and better. So it's getting better all the days. I remember the times 10 years ago where everybody was talking about focus shift, and which was a problem of heating up the bulk material and distortion, bending of glass. This is not that problematic anymore. So when we, for example, talk about cutting, we are talking about cutting heads which need to stand 30 kilowatts nowadays, and this is, and there we don't have any cooling devices. We do implement some apertures to get rid of vagabonding photons, let's put it like that, and to just get these photons of the laser source through the optics, which are important. But cooling, to cool glass, it's quite a challenge, and that's why we do have some cooling, but we try to get rid of cooling as much as possible.
Let me introduce you to a friend of mine, because I love Precitec. I don't know if you noticed that. And I have a friend of mine here that is very good at cooling any kind of system. Torsten from AMS Technologies, all the way from beautiful Munich. How are you doing?
Good.
Can we do something with Precitec? So he's very happy of being at this meeting.
Yeah, of course, I know Precitec. It's also a customer of mine, especially their branch in Neu-Isenburg. And of course, we can talk offline on cooling. So AMS is doing a lot regarding cooling of lasers, of high power optical equipment and things like that. So I'm not the expert for the cooling itself. So we do a lot here in AMS in water cooling, in compressor-based cooling, direct evaporation cooling and things like that. So I can bring you in contact with the engineers here in our thermal management team if you wish.
Okay, thank you.
Very good. Then I guess we have already some connections. And then going back maybe to your wish list, Markus, I guess you were talking about also laser and beam shaping and beam delivery. And I know that Gwen here in the room would really like to show a little slide of what K-Labs can do. There, well, already ready to go. So
yes. When I was trying that with you just before, I was a little bit slow. So now I try to be a little bit faster.
No problem.
Thanks, Francesca, for giving me the opportunity to talk after Markus just today to this very nice meeting. So yeah, what can we do, K-Labs, and what can you do for us regarding laser beam welding? Well, basically, we do beam shaping to improve laser material processing at K-Labs based on our MPLC technology. And we have catalog references and custom development for all those kind of applications. Just want to say that we are doing beam shapers that we want to make them compatible with laser heads like Precitec heads. Actually, in this module that we did manufacture, there is a Precitec input and a Precitec output. And we are already handling 16 kilowatt at K-Labs. So that is the kind of thing that we are doing that we want to bring to the world of laser beam welding. So what can people do for us here? Well, basically, we are looking for new challenges. And I'm very sure that actually Markus has many in his head. I know actually he has many in his head, and we are looking for end users who want to try new kind of shape to improve the processes, or who want to collaborate within very large projects. So if Francesca, you allow me, I will have one question now for Markus. Markus, you do a lot of R&D at Precitec, and you are always trying to improve all the processes with new features. What would you expect from laser beam shaping to bring to laser beam welding?
Gwen, for those who don't know that K-Labs and Precitec are working together, they can come to a different webinar on Monday. No, nevertheless, Gwen and me, we are talking about that for some years right now, and we definitely see that beam shaping is a quite important issue. And we have seen that when some years ago, Armada started with the NZ system, and there were some following. Trumpf is now following with the Brightline fiber technology. So we see that there is a benefit in bringing the right photons to the right position at the right time in the right power level. So I always say that there are the research institutes, and we do have some research institutes here in the group today as well. Research institutes are the ones who who are responsible for programming some kind of GPS system for photons. So the research institutes have to say, what is the rest position for the photons to hit the workpiece surface? And Labs is the one who is taking over that information from the research institute that is building the MPLC system in order to fulfill the demands of the research institutes. And that MPLC system is adapted to a Precitec welding head, and then we fulfill all the important applications which are coming today or in the future. And definitely we see if there is the right beam distribution, power distribution at the workpiece surface, processes are running better, more smooth, with less errors, and that helps everybody to bring more lasers into production.
Great, thanks a lot, Markus, and thanks a lot, Gwen. So we saw already an example of collaboration. I'm also writing down all these vagabonding photons, GPS system for photons. These are all things, Markus, that I will not forget, because they're really catching really the attention and the meaning of what you need for your system. So thanks a lot. So now it might be time to go all the way to Israel. So it's time for Eyal to talk about Civan advanced technology. So the floor is yours.
Thank you very much. I'm very happy to be here. And actually, it worked out very well to put me right after Precitec and Labs. It's going to make my presentation really flow with everything that was said until now. So just a few short bullets about who we are. So Civan, we're based in Jerusalem, Israel. We were established in 2008. And what we do is high power lasers. What we do is high power lasers for material processing. I'll explain in a minute how we are different than any other lasers. So established 2008, we are 180 people. We're working from a facility of 3,500 square meters. Roughly half of it is clean rooms for the production and R&D. We're a vertically integrated company, so we do all the core technology in-house. So I want to show here two of our product lines. So one is the high power single mode fiber laser with the dynamic beam. So what we have is lasers from 10 kilowatts and up, actually even higher than 30 kilowatts with a single mode output. And this single mode output has the ability to change shape, position, focus, intensity, all at hundreds of nanoseconds speed, and do beam shaping and so on. I'll show a few examples in a second. And the other product line is a green laser. It's a single mode green laser. I'll show in the next slide that what we do is coherent beam combining. So basically we are able to get to really high powers with a single mode output. So that allows us to get to the extreme high power in fiber laser to many tens of kilowatts with a single mode output. And in the same method, we combine green modules, single mode modules together to have a single mode output with hundreds of watts of single mode green CW output. So really the core technology is coherent beam combining, where that means that we can take many amplifiers and combine them together to have one single mode output. But in addition to the fact that it's single mode, we also have control of the beam position, beam shape, beam focal distance, and so on, because as you may know, we're using a technology called optical phased array. Optical phased array means that many lasers are shining together on a common output, common far field, and in the far field you create a diffraction pattern that by controlling the relative phases, you actually control the shape and position of this output beam. So this output beam is a single mode output, but the position can be changed, position, shape, focal distance, and so on. So here you can see a few examples of just any arbitrary shape that one would like to do. So we're showing here some shapes that many people are doing, like the wobble, the H shape, a circle with some intensity in the middle, but then you can have 1 point, 2 points, 3 points, 4 points, 5 points, really any arbitrary shape. And just to show the fact that you can do arbitrary shape, we show here our logo, which is here at the 14 kilowatts output. And of course, I don't have to explain too much the importance of this beam shaping and beam wobbling. So I just show here a few examples from our application lab showing different cross sections of bidon plate with different beam shapes. So the way we are different than any other method of beam shaping is, first of all, we can do any arbitrary beam shape, okay? It's absolutely, so to speak, random access. Whatever you can draw on a piece of paper, we can get close to, at least in the shape. I'll show in the next slide something about this. We can change the frequency of oscillation. So for example, if you want to do a wobble, you can do it at kilohertz or you can do it at megahertz. And all you have to do is choose on the computer what speed you want to do, and it happens. Another very interesting thing is that all these changes between different beam shape, different focal distances can be done on the fly. So for example, if you're drilling two materials and you want to go from one material to the other and going through the interface, you can actually every microsecond change the beam shape. So as you drill, you can change in one material with some beam shape, and then in the interface, change the parameters a little bit so you go smoothly through the interface. And then when you come to the other material, change again. And of course, for welding and cutting, it's the same idea. So all these beam shapes are actually very easily created. We have a very simple software that one can just mark the shape that they want. And in every point here, you can say how much intensity you want, okay? So the shape, the relative intensity in every point, and even the order by which the beam is going to go from one point to the other, you all design it here very simply. Immediately you get a simulation of what the beam is going to look like, because, of course, because of the physical effects of the far field diffraction pattern, you can't get anything you want. So for example, you can see here our logo, the way we designed it here compared to the simulation. So you see there are all kinds of lights in places that we didn't want the light to be, but at least you know in advance what the beam is going to look like. And here you see it at 14 kilowatts, it's very, very similar to the simulation. And here another, the Star of David, just you can do the design, you get the simulation, and then in real life, you get very similar result to the simulation. So the point is that really, and I don't have to tell this audience that every specific process, every specific material needs a different beam shape. For cutting is different than welding, thick material or thin material, stainless steel, aluminum, titanium, any material needs something else, and every process needs something else, because maybe it's a crack sensitive material, maybe different parameters that you have to control. But the point is, with our laser, it only takes minutes to design any shape you want. And then you can really do tens of shapes. You design the shape, you put it in the menu of our laser, and with a pull-down menu, you can choose any shape. And in a matter of minutes, you can do tests of tens of different beam shapes. No need to change any optics, no need to change any mechanics. Just by press of the button, you change the shape, you change the frequency, and so on. So this is for designing processes, and of course, maybe in the future, some of the things that Precitec mentioned, you can do on-the-fly monitoring, and because we can do on-the-fly beam shaping and change all the parameters, you can actually in real time close the loop, and as you monitor the process, you can actually change the beam parameter on the fly to improve the process. We have an application lab where we test all these things. So what you can see here in the picture is a 16 kilowatt laser with a dynamic beam. And we have here a simple XY table. This is the control room where you control the laser, the beam parameters, and you can see the processes it's being done. And then we have a small metallurgical lab where we can do all the cross sections. And you can see here just one example how different oscillation frequencies completely change the shape of the cross section, the behavior of spatter, porosity, and so on. And this, for example, this report we did about 100 tests in just a few hours. It took more time, of course, to analyze than to do the actual test, but really just change from shape to shape, frequency to frequency takes minutes. So in our lab, we demonstrated welding, drilling, cutting of different materials with different beam shape and frequencies and so on. And to answer your question before you ask it, so what we are very interested in is your problems, what processes people are having difficulty with, what materials, and of course with the e-mobility. I think it was mentioned before how new materials and new processes require both beam shaping and also the green laser, our single mode green laser. And we will be very happy to demonstrate the capabilities in our application lab, and hopefully more than that.
Thank you very, very much. I mean, it's fascinating. Your special light modulation is just out of this world. I was impressed. I really cannot believe what you can do with a beam shape. Are there any questions for Civan? Because I really want you to meet some of my friends, because you have to come more often to the EPIC meetings, and I also have to go more often to Israel. As soon as the whole thing goes back to normal, I'm going there. But I want you to meet the people that I have in the specialty fiber business. I'm going to go to France. I'm going to go to my favorite guys from IX Blue. Thank you very much for being with us today, Emmanuel. What did you see about this presentation interesting? How can you do something together here?
Hi, everyone, and thank you, Jose. Thank you to give me the opportunity to talk about IX Blue and to talk about your activity and product. So we are a French company, and I'm from the photonics division, where we produce optical fibers, spatial doped and passive fibers in a wide range for 1 micron to 2 micron application, and we produce also fiber Bragg ratings for different applications. So we have a lot of standard references, but we appreciate challenges with customized requirements. For example, we can propose solution for high power laser cavity with spatial active and associated passive fiber. We know that it's very important to take into account splice quality between two fibers, and we have the same approach regarding FBGs. We are really interested in all applications where high power is required.
When it comes to FBGs for high power, you are knocking at the right door, Eyal. You are looking at the iX Blue door. I always like introducing you to a customer and a supplier. First, I started with the supplier, so you have to buy some FVGs from them. And I'm going to go to a customer. I'm going to go to my very good friend, Dirk de Man. Goedemiddag, Dirk. Thank you very much for joining us today. Are you looking for some high-power lasers to put in your beautiful workstations?
Go.
Yeah, we can hear you.
Yes, hello. It's great to be here again and to meet so many friends. I let to see one of my, it's a robot of Comau. You can see of Comau. And I know Comau quite well, so we know their robots. And I used to work with Comau robots in the past a lot, so I know a lot about that. And of course, I know Trumpf and also a lot of other players here in the industry. If you look at how we can use your technology to provide groundbreaking new technologies for our suppliers, I see a lot of potential here, and I'm very happy to hear what is possible so I can translate that to our OEMs who we're happy to serve.
It is great to have you in the EPIC network. I'm coming to visit you in a couple of days, as you know very well.
Yes,
and I'm going to go
now
to the other side of this beautiful planet. I'm going to go to Canada. I'm going to go to my friends from TeraXion. I'm going to go to Claude, because Claude, what can we do to make TeraXion a great company, even greater? The floor and the attention of everyone is yours.
Yes, let me find my share screen. Okay. Share. Is this working fine? Yeah, good.
It's crystal clear.
Thank you, Francesca. Yes, TeraXion. We are a company based in Canada, as you mentioned. We're in the French-speaking province of Quebec. And what can we offer to the welding ecosystem? Before that, if we look at, what is TeraXion, we were founded in 2000. We're based in Quebec City in Canada. We are more than 170 employees. We do design development and we manufacture optical components. We're addressing three main markets: the laser systems, the high power fiber lasers, which is part of the topic today, and also ultra fast lasers. We also address optical communication, which was the market that founded TeraXion. We were one of the leader in chromatic dispersion management for the telecommunication industry. And also we do have activities in optical sensing with specialty semiconductor lasers, specialty filters. We are in providing components for LiDAR, wind sensing, and autonomous vehicle as well. We have three main technological expertise. We are expert in fiber Bragg gratings. That's our main technology that was used to found the company. We later on acquired the expertise in low noise lasers, semiconductor lasers, ultra narrow lasers, and highly stabilized lasers. And we also have a sizable chunk of our activities in integrated photonics. Now, for the high power fiber lasers, which is where we're a player in the welding industry, I will assume that a lot of you know these configurations, but also that some of you might not be so familiar with it. So in high power fiber lasers, the basic building blocks of the fiber lasers, we combine these single cavity configuration and a single cavity combination. We combine several of them to output the high level of power that were mentioned earlier in other talks. So a single cavity can go up to 2 or 3 kilowatts. And where we are integrated into these building blocks is the FBG fiber rack gratings that are used for acting as the reflector of the cavities. So we have an eye reflector and an output coupler. We also have a product that is used to manage the Raman stimulated scattering. We have a Raman suppressor that is inscribed into the fiber, either the delivery fiber or the passive fiber of the system. And we also can be integrated into the other types of configuration, like the MOPA, where you have a master oscillator and a power amplifier at the output. What are the challenges in the high power fiber lasers? If we take it on the industry process requirement side, the industry is always seeking highest throughput per dollar, and what is required of the laser is to have low dollar per watt in essence, and that's where we have benefits with the Raman suppressing filter. When you reach the high power, you run into nonlinear limits with the Raman scattering. And to address this limitation, by suppressing the Raman, you can increase the output of your cavity without having to go to, in some cases, more single cavity combined together. So in essence, you can use less number of single cavity to get to the final output. Another industrial process requirement is, and this is something that was addressed today by several presenters, the processing stability, which is key for the welding. And at the laser requirement, it needs to be a high power stability and also high beam pointing stability. And again, the Raman suppressor is a key element for reducing the Raman and improving the power stability, since the Raman is a bit stealing power from the usable wavelength. Another aspect is the beam pointing stability, and it allows, the Raman is allowing the systems to reach the other limit of most of the system, this limitation being the thermal modulation instabilities. So the fact that we can use a single mode fiber can help in that sense. Another process requirement is to have no downtime, and we need to have laser high stability, high reliability for that. And by having a Raman suppressor, we have some level of immunity to back reflection going back into the cavity. And if you want to have more details on the benefits of the Raman suppressor, we have put in reference an article we have presented in the last Photonics West. The high power component, when we look at the fiber back grating themselves as a reflector in a cavity, the product we're designing and manufacturing have the capability of handling power up to 3 kilowatt depending on the fiber type. We're working with the different popular wavelengths with 1 micron for the ytterbium lasers, 1.5 for erbium, and the 2 micron for the thulium lasers. We also work with different fiber types and diameter. We have we work with colliding diameter from 125 to 700 micron, and even outside of these, but those are the most common ones that we are a player in. On the left side here, we see the package of these reflectors. They are there to handle the heat dissipation. And lately we have new products that we are able to have so minimal loss, and we address the power handling so efficiently that these packages are no longer required. The Raman scattering suppressor, as I mentioned, it enables the power scaling of your laser by outputting the unwanted wavelength of the Raman outside of the core of the fiber, and by doing so, it will improve your laser stability, since the Raman band will use up some of your desired wavelength as a pump to the Raman. So it is suitable for oscillators up to 3 kilowatt, for MOPA up to 5 kilowatt as of now. We're mainly working at the wavelength band of 1 micron. We've manufactured these products in core size from 20 to 25 micron, and from cladding size from 350 to 600 microns. Now the questions is what EPIC members can do for TeraXion, and what we can do for you. So for the community, we provide high performance, high reliable FBG reflectors and filters for high power fiber laser application. The reliable aspects that we provide is coming from our background in telecommunication. It was very key to be reliable, and TeraXion has made a name of itself, being a reliable, providing reliable component for the telecom industry, and now since already many years for the laser fiber industry. We are expert in dispersion management. This is useful for the ultra short pulse lasers, where we do offer different products. We provide the customized component for new innovative fiber based lasers of various fiber types: single mode fiber, large mode area fiber, multi-mode, multi-clad, multi-core, and others. We have a traditional UV and also femtosecond through coating writing process for FBGs, and a solution to reduce your dollar per watt by improving your laser stability and reliability. And what we're looking for from the EPIC members, we are always seeking in-depth understanding of laser design and application challenges. TeraXion, we have made a reputation of ourselves as a company wanting to understand what they're doing. So we are strong in modeling everything we do, but to be better, we always need more understanding of application challenges. So we're looking for a partner to test our FBG-based products at extreme power condition. The limit of those systems is always pushing the limit. These systems are used in very harsh condition in some countries, and we always in the lookout for partners to test the limit of our products, and also collaboration to develop added value products. This is always something that is on our roadmap. So thank you for the time.
Thank you very much, Claude, for your contribution.
My pleasure.
So let's go back to the room. So this is definitely a talk for a laser supplier. So there are some in the room. If someone wants to comment or ask questions, otherwise we put you definitely in contact. Maybe Claude will tell us. Maybe some of you are already working with them, some not.
Oh yeah, we are working with some of the people here.
Okay, very good. So we will find maybe later on, you can tell us offline if there's someone that you really would tackle. But now maybe we could a bit go on with our round in the audience. And I was thinking about that Fraunhofer IWS, so the lasers of the future for welding. Maybe Jens wants to introduce himself and the work at Fraunhofer.
Thank you, Francesca. Fraunhofer, I think, is well known as one of the biggest research organizations for application-oriented research. And we here at Fraunhofer IWS in Dresden are working for lasers since more than 20 years in the micro and also in the macro field with high power and with low power lasers. I come from the high power side, from the welding side, and what we are doing or what we are working for in the last years is many of things. What happen if we have some possibilities to beam manipulation, to adapted, let's say, intensity distribution, and in the past we do this by, let's say, using scanner, and now we have very new and challenging opportunities to do this, let's say, with other somethings like Eyal present these possibilities for beam shaping offers a quite range of application, of new application, and our topic is for research is more to understand what's in behind and how can we predict the behavior at the end of the process. And this is a topic of the future, maybe for different application, what is shown for electromobility, for copper welding, and as well as for aluminium welding. And I think in the future that is quite challenging thing, and I invite all to talk to us what is our experience, what we have done here, like for beam manipulation with high-speed scanner. That's our topic, where we try to, let's say, bring the line from the laser, from the systems up to the application, and that is our topic. And we'll be happy if we have some contacts here. Thank you, Francesca.
Very good. This will be done for sure. So if you wanna, you're not only looking at the system of the future, you're also looking at the future of the devices. So we heard before, for example, the aging process that is also acting during welding. So this is maybe something that you can discuss further on, I imagine. And then all the monitoring system is really interesting to hear. Then I guess now we can finally give the floor to Michael, Michael, yeah. From IPG, so I'm really happy that we managed to have IPG Laser today in the room. So the floor, Michael, is yours.
So, thank you, Francesca. Thank you for having me here and present IPG. In this audience, I want to share my screen. Can you see my screen? Are you ready?
So far, I see it black. Maybe it's slow for me to get. Takes a while. Okay, maybe, should I maybe share your screen? And we see if it works better for me.
So if you cannot see, you can try.
No, yes.
Now it's there?
Yeah.
Okay, so thank you.
But it's still not in presentation mode. If you just make it in presentation mode,
I switched to presentation mode sometimes.
Okay, but then maybe it's the wrong screen. Maybe you can easily just unplug the screen, the second one. It's the easy choice.
I have just one screen.
Okay. So then you maybe just pick up the wrong. I guess I don't see that you are in presentation mode. Maybe you should click below. There is the small icon on the bottom right to say presentation mode. Or also Bildschirmpräsentation, the first choice.
So it seems to be very slow now. Maybe you should share it.
Okay, then
I don't know.
I guess I have the PDF of yours, I guess.
Yes.
It's okay. I guess I can.
It's okay. So I have no videos inside now.
Yeah. So let me check. Okay, now I'm set myself. Let's see if I get it now.
So sorry for that. I can see it now from Francesca. Thank you very much. So I want to talk a little bit, so it's a short time for about superior welding for materials for e-mobility. So my name, I already was introduced. I'm Michael from IPG. I'm the head of the applications lab here. And so I want to tell you a little bit about our technologies in e-mobility. Thank you. Next slide. So first, a few words about IPG. I think most of you will know IPG. IPG is on the market now for quite a long time, founded in 1990s. We have an installed base of laser systems for more than 100,000. We shipped last year, 2018, 43,000 devices. We have more than 6,000 employees now worldwide. Here in Germany, between 1,000 and 1,500. We have about 2/3 of all fiber lasers manufactured worldwide are coming from IPG. And these fiber lasers, which are really high efficient, which have an average, let's say, wall plug efficiency of about 40%. So we save a lot of CO2. So let's see, that's green technology, what we are producing here. So around 28 billion pounds less global CO2 emissions when operating IPG lasers compared to other lasers when we look at the last, let's say, decade. Thank you. The next slide, please. So we have IPG has application researchers and application labs worldwide. Meanwhile, we have 25 of these application labs, 9 in the USA, around about 8 in Europe, and the other in Asia, Japan, China, Korea, India. So worldwide, we have our applications labs, and we are ready and we are willing to support you to optimize your processes, to choose the right lasers for your processes, and to demonstrate our capabilities and our technology. Next slide, please. Yeah. We want to talk about e-mobility. When we talk about e-mobility in welding within e-mobility, we mainly talk about high reflective materials. This means this is copper, this is aluminum, this is high reflective stainless steel, but mainly we are talking about high reflective materials. And as many of you know, or all of you know, the shorter the wavelength, the better is the absorption for the lasers on these materials, especially for copper. We know that the green lasers we heard already today, or blue lasers, have a better absorption. But this is valid for the solid state. To overcome this absorption, there are different, we have problems when using the infrared lasers, especially at the beginning of the process when we have these solid state lasers. What we can do to overcome this is to apply a very high power densities. This, for example, can be done when we create a keyhole in a very, very fast time by using single mode lasers. With single mode lasers, we can create high power densities and create a keyhole very fast and then get stable processes. Another technology we meanwhile have is the so-called AMB technology, adjustable mode beams, which means that we have a double laser that has a laser in the core of the fiber and a ring around this core. This is available with different ratios, different diameters, let's say 50 micron, 150 micron ring, or 100 micron core, 300 micron ring. And these lasers are utilized to optimize processes. We get a preheating of the material by the ring, we get a soften of the keyhole, and in this way we can eliminate spatter, for example, and enable really high-speed copper welding processes. Maybe you go back very short. Yes. To finish or to make a package of all these technologies, we have an additional new technologies in-house for copper welding for real-time monitoring systems, which is called our LDD system. Next slide, please. So I already said we have to overcome this low absorption, and this is done by means of the high power density. When we look on the left side, we see this table where we see in solid state, we have just 4% of absorption for the infrared. laser wavelength. But as soon as we overcome this solid state, we come to the liquid state, to the keyhole, to become suddenly to 60% and more of absorption of the infrared. And this is not much less than for other wavelengths like green or blue. And in the same time, when we then go very fast with this high power density, we can create very stable processes. As I cannot point now with my mouse, so you have to look at the center. I have to explain where you should point your eyes. So we see a very stable weld on the right side and a very unstable weld on the left side. Thank you. On the one side with a low power density, on the other side with a high power density, which means as soon as we create a stable keyhole, we also can create a stable welding process. And when we, for example, on the right side, we can see that if we double or if we reduce the spot size to the half, we increase the power density 4 times. This is just the area of the spot on which we can apply this power. So the single mode lasers today we have in a range of a few watts up to several kilowatts. So typically applied in e-mobility, we are somewhere in the range between 500 watt and 3 kilowatts most of times. And this is the right power density and the right power to create very stable processes. So we can choose here, or we can create here keyhole depths of a few tenths of millimeters up to a few millimeters, 3 to 4 millimeters. Thank you. Next slide, please. So this was the only one technology, the single mode lasers, and the other technology I already mentioned is our new technology of the adjustable mode beam. So we get a very broad range of beam profiles. This means we can separately adjust the power between or in the ring. We can separately adjust the power in the core and play with these parameters to optimize our process. In this way, we can create also wider weld beats, narrow weld beats. We can increase the quality of the weld seams. We can create really high-speed welding, and we can really get consistent welding in thick and thin copper. Another options to optimize this weld quality, which is always the main key in copper welding, is to apply dynamic beam shaping. Dynamic beam shaping means that we apply scanning heads or wobble heads to move the beam very fast. It is known that a fast movement of the laser beam stabilizes processes in copper welding. And this is what we can do in a very limited space, for example, in a small circle or small lines, to get really reliable high-speed welds on these high reflective materials or dissimilar materials. So we get very aesthetic finishes of the welds, for example, for sealing of battery cases, for connecting battery taps to the battery cell, and stuff like that. So this is really consistent, very stable processes at very high speed by means of the scanner. So we can produce, for example, several tens of welds within 1 second on, for example, a cylindrical battery cell. The other, as I already mentioned, the other system to improve and to guarantee the quality of a weld is our inline depth monitoring system, very similar to what Markus from Precitec already presented. We call it our LDD systems, a laser depth dynamic system, where we can look into the keyhole, where we can measure the depth of the keyhole, where we can post-weld inspect the weld, or pre-weld find the seam. So this is a multi-tool, one tool for several applications and several tasks for measurement. So we have a quality assurance, inline quality assurance tool, which directly gives out the values you measured in time. Next slide, please. So with this package all around, if we summarize all this, so we have a quite nice technology with available lasers. So as I said before, the initial absorption rate of our adjustable mode beam laser, but also on our single mode beam lasers in the infrared rays is lower, is much lower than for green and blue lasers. But as soon as we get a keyhole created, we have the same stability and the same, let's say, absorption for the wavelength. But when we use the infrared technology, this is a proven technology. These are lasers which are produced in really high numbers. The initial cost, that means the cost of ownership, the investment costs, they are quite low compared to this new technology of the green lasers, of the blue lasers. These are field proven and reliable technology. So since 10 and 20 years, we have these lasers in production. We have a very high, we can scale the power up to 25 kilowatt from a few watt to 25 kilowatt. All is available, different beam qualities. We can create very high welding speed as we have a lot of laser power available. We get deep penetration, very high penetrations, as we can have very high power rating and high beam quality. We can control the interface by our scanning technologies or by our AMB technologies. And we have a lot available standard laser components. This means welding heads. So all these welding heads and other technologies, scanning heads, they are all, not all, but mainly optimized for the infrared wavelength. This is all available. So there's nothing new, there's nothing which has to be invented. So with our lasers, with the AMB especially, we can offer green and blue capabilities, but at a much higher reliability and much more flexibility and less costs. So I think this was already the last slide. No, one last summary once again. So just we can create superior welding quality of materials for e-mobility. We virtually eliminate the welding spatter by these technologies. We can have a scalable power output. We can control the interfaces. We can increase the weld quality. We can really get a high-speed welding. We can have a very large processing windows as we have the optimized these possibilities to move or to have this dynamic beam control. And as I said before, just to summarize once again, these are all standard components which we can use, which are very VR compatible. So that's the end of my talk already. I was limited to.
Thank you very much, Michael. That was a great presentation. This is your epic re-entry. You've been here before, but this is your epic re-entry. Epic has changed a little bit. Now it's about cooperations, collaborations, working together. What can you do for them? What can they do for you?
Yes, what can we do for you? So we as IPG, we can, of course, we can demonstrate our system to you. We can give you the opportunity to visit us, to test our optics, to test our lasers. So we have the full range of beam sources in our application labs worldwide. So you are always welcome to make tests with us together. What can you do for us? Of course, you can support us with your technologies, from your optics, from your devices, to serve our customers, to make processes better, to make our customers happy. And yeah,
your customers are already very, very happy. You have great lasers.
Of them, I guess.
Yeah, one thing that I would like to ask you is just select one challenge for this audience. One thing that you think, oh, if I finish this meeting with a potential cooperation on this aspect, I'm going to start such a great weekend.
That's not so easy to say one thing. I think it's a great opportunity to have all these specialists and experts together, to know each other, maybe to see each other for the very first time, and maybe make the communication easier and the relationships easier. So that's the great opportunity. What we have.
And to meet them, and after the meeting, I'm going to make a lot of introductions, and people are going to get to know each other. I'm going to introduce you to a very good friend of mine. Ciao, Fabrizio. Come vai? How are you doing today?
Ciao, Jose. Hello.
I have put you today in front of a lot of high-power laser manufacturers, and I think they're going to tell you I had to wear the goggles when I use the laser welding. How can you help these people?
Absolutely. It's very impressive. It's very impressive how the power is going up every day. And from our point of view, is a challenge to follow them to protect the eyes of these guys, our eyes, and the guys of the users, the applications, the end user, and so on. So we are developing always more and more protective glasses, filters, and goggles. Not only, but the protection windows for the systems too. And for Raman effect, for Raman scattering, I listen, TeraXion is from Quebec, is offering the FBG suppressor, and that's absolutely a very good thing. But in case there is not a suppressor, we are ready to provide any protection for the secondary and the third emission of the Raman effect. So I really congratulate everybody because are super investing and super focused on the R&D with, as now I listen, adjustable mode beam from IPG, and is something new that is always going to better perform the laser in many welding applications that up to few years ago were impossible to think to use it.
Indeed, Fabrizio, and I have to say that when I have been talking to you for many years, I have been wearing your goggles in many different applications. You always tend to think about the person who's going to wear them. And that's something that defines Univet. I'm really happy to have you in EPIC. And you are right. The lasers are getting more and more power, and there are challenges on both sides, on the eye safety, but also in the power side. And for that, we had the next presentation all the way from the beautiful country of the Netherlands. I love their windmills, and I also love the power supplies. PVF, thank you very much for this beautiful cap. The floor and the attention of everyone is yours.
Thank you. I will share my screen now. Hang on a moment. Yes. Is it okay, so?
Yes, perfect.
Okay, thank you very much. Yes, I'm René Dingshoff from PBF. First, I'd like to introduce the company PBF Group, located in the Netherlands, headquarter. We have also a company in Romania. We are a former Philips company, but are on our own now since 1999, have 120 employees, and part of a bigger group, the SFC Energy Group, with the headquarters in Munich in Germany. We have special power supplies for welding applications, and we have a wide range of them. So we start with 7 kilowatt, 14 kilowatt, and 21 kilowatt, and we have it in a wide variety of output voltage and currents. So basically, for any welding application, we have a power supply, and that's a current source that suits probably your high power application. They have, of course, a 3-phase input. As I mentioned, they are current sources and have fast rise and fall times, so to make any desired pulse that is required for high power welding. You can use it on a wide output range, so I come to back that later. They are water cooled, since your lasers are also probably water cooled. This fits very well in your application, and they have a very low ripple output current. And what makes it unique is that it has an integrated safety interlock according to an ISO standard. It has the highest possible grade, so the PLE. That means that you can leave out a lot of your safety components, and you don't have to switch off every time the mains when you have a safety issue by opening the door or whatever in your application. I will explain it later in a bit more detail. So first of all,
I like to introduce you the LAPS 21000. As I said, we have it also in a 7000 and 14,000 watt version. But I give you an example of the 21 kilowatt version. It can, I just take an example of the 90 volt version. Actually, I made a mistake here. It must be 360 amps, so excuse me for that. You can see here that this is the output current. We can draw to 360 amps from it. And at this point, you decrease the current, but you can increase the voltage. So in this area, you can use the full 21 kilowatt. So basically from 59 to 90 volts. So it does not matter if your laser works on 70 volt or 80 volt or 90 volt, you can use the full 21 kilowatt. As I mentioned, we have a safety interlock integrated in our power supply. And I first like to introduce you how many of you probably will do it right now. You have a big contactor, and probably you have two because of the high level of safety that you want to achieve on your system. And you have a sensor that can be a door sensor, that can be a push button, that can be or a computer, whatever, telling them e-stop relay that you have to power off your system. But every time you power off your system, you power off the mains. So in a power supply, there's a big energy buffer. It is depowered, and you lose basically every functionality of your power supply. And every time you go back in operation, you have to power up the relays. Then the energy buffers inside the power supply have to be charged. This will take some time, and it gives the power supply a lot of stress because there are inrush limiters and etc. So it's not really recommended for a power supply. Also, every time you switch, you reduce the lifetime of your contactors. And if you do the analysis on your safety interlock, your e-stop circuit, it shows you that after so many switches, you have to replace your contactors to ensure the safety of your complete system. So this way of doing it has some disadvantages. Like I mentioned, the contactor's life is limited. You need time to energize the system. That might take 2-3 seconds. But if you open up a door for changing a component or whatever, it reduces your uptime quite a lot. And like I said, stress on the power supply. And if you have a very large system, you will see inrush spikes on the net, and it might even disturb other equipment. There's also a PBF way of the interlock. We have integrated the interlock in our power supply. So you don't need the contactors anymore. And it's even possible to do it without a safety relay because we have the PLE system inside. What are the main benefits? Like I said, no contactors. And you have now a very short time to energize or de-energize your system. This not takes seconds, but a couple of milliseconds now. So your uptime of your system can improve quite a lot. You don't have inrush spikes anymore on the net because the main buffer inside the power supply remain powered. So there's no need for inrush anymore. And like I said, it is even possible to also get rid of the each stop relay, but that is really dependent on how you build up your system. So PBF has a large scale of power supply specialized for laser. As you see here, we start with 120 watt, and the biggest that we have at this moment is 21 kilowatt. We can supply you with voltage sources if you have your own current drivers, or we can supply you with complete power systems, including current drivers that you can directly connect to either your fiber laser system or your diode bars, or basically any laser. Lasers are very dynamic. You have pulse loads with any kind of frequencies. So these power supplies are specially designed to handle those loads. And we have them water, base plate, or fan cooled. Focusing a bit more on a few of our products is, for instance, the LAPS 3800. As you can see, it's a base plate power supply, but you can mount it on a water cooled plate. We can deliver both with or without a plate. It's specially designed for pulse loads, and it has three-phase universal mains. And when we say three-phase universal mains, we mean without any derating. So from 180 volt face-to-face to 530 volt, you can use the full power. You can put them in parallel or in series to either increase the current or raise the voltage. And if you see this example, now we have two, but if we put 4 of them in parallel, you have in one 19-inch more than 15 kilowatt. You can program the output voltage, and it has an excellent dynamic behavior. That helps you designing your own current drivers and makes your design much easier. So this power supply is typically used as a front end, and you have to put your own laser drivers behind it. Another supply on the other end is, like I showed you, the 1400 or 21,000 watt power supply. It's available in different voltage and current configuration, water cooled, has fast rise and fall times, and a double safety interlock. As I showed you in previous slides, that can reduce external safety components and optimizes the uptime. So yeah, this is basically some of our products. We have much more, but you can always contact us or look at the website. And basically now we come always to the part that they want to ask questions or not.
Yes, very good. Thanks a lot, René, for your contribution. So this is definitely a product for laser manufacturers, so for the core of our systems. So if someone has some questions to René, we can take them, some comments. So if it's not the case, is maybe time we could go to OPTOPRIM. So we have 2 representatives here, so please don't fight for describing what you are doing. So we maybe start with Stefano, or if it's the best choice. There you are.
I would have preferred Christian would have started.
Okay, then Christian is in, and now you cannot give the microphone away.
No, I will start. It's first of all, thank you for hosting this meeting. OPTOPRIM is a distributor of laser components in Europe. We represent some of other people that are in this meeting. For example, Laserline, Univet, and Light that is not here. So our company, the aim of our company is to promote laser technology. We have in Italy an application center where we can support our customer for application and get them closer to the process and to the possibility to realize what are their needs. So this is basically our job. Okay. Christian, if you want to add something.
I guess this was a nice picture from your company. So of course we are also welcome also offline also to collect possible connections you want to have with these companies. Many you know already, many not, others not. So we are really available for this. So now we are ready maybe for a challenge. So the first time that we show a talk while the presenter is on the phone. So Matthias from Excelitas, do you hear me now? So I see you are muted, you are there, but I would share your slides if you are ready to roll. If it's not the case, maybe we can postpone because we have other speakers, but just to know, I gave you, now I see you are muted. Matthias?
Okay.
Yes, we hear you.
Yes. Okay. Okay.
Okay. So now let me.
Yeah.
So I now share my screen.
Sorry for all. First of all, sorry for all the inconvenience. It is my home office. My home office is in the cellar. Internet broke down, and I looked at the YouTube live video screen. This is just about 5-6 seconds. So if I try to skip my presentation, or Francesca, you will do.
Yeah, so
it's really hard.
Let's do like this. You look at your slides, and I say. So now we are showing the first slide. When you say next, I go to the next one.
Okay, Francesca, thank you.
You're welcome.
So my name is Matthias. My name is Matthias from Excelitas Optics. And the next slide. Excelitas is a American company. It is now is a very famous history and an old history. So Excelitas started in the 1931 in the US, and in 2013 Excelitas bought the Optic. The Optic has many different famous brands. So started with Rodenstock, Spindle and Heuer, so mainly a German, European company. So all over Excelitas we have 6,000 employees, and the Optic we have 2,000. So 2,000 within 6,000. Next. So the portfolio of Excelitas is a very, very wide portfolio. So we have on the emission illumination side, like xenon, flash lamps, LEDs, lasers. We have transmission optics, like optical components, optomechanical assemblies, photo lenses, professional photo lenses, and we have sensing and detection. So thermopile sensors, high-speed sensors, low light level sensors. And we have as well electronic like high power supplies or power supplies for LEDs and so on. Next. So we are talking, or I'm talking today about the material qualification, the material we are using in our optical systems. The material is one of the most important things, I will say, because I'm coming from the material side. It's similar to a Formula One car. So the power, the engine of a Formula One car, and I will compare the engine with the laser source manufacturers like Trumpf, Laserline, IPG, and Civan. So you have to bring the power on the track, and at the end, the tires, excellent tires you will need. And so I will compare the tires at the end with the optics at the end. covering the material at the end, and we talk about the fused silicon material because the demand from the market were coming 10 years ago that we need and we have to use fused silicon. And so we started this process of material qualification because the availability and the raw material price trend always changes and increase, decrease. And for us, it was interesting to optimize the internal manufacturing processes. And as well, we looked on the performance consideration. And at the end, it was very important for the customers, for our customers, to have a quality improvement. And this all ends up in the increasing high power laser market. The laser system is running 24/7 in the industrial market. So what have we reviewed and compared with the fused silicon material, our lenses? So we compared many different standard manufacturers of fused silicon all over the world, Europe, US, Japan, and China. And we looked on the delivery dimensions of the raw materials and their tolerances. And for sure on the prices and the supply chain, because it's very important to have the material, and we need tons of material of fused silica per year. So the supply chain has to be secure. That's very important. Next. So, and this was the material side, and now we're going into the design side. So we design our lens systems for high power laser applications in-house. And so we look first on the transmission versus wavelength on the different materials. Here in this chart, you see, for example, areas, Corning glasses, and you see they perform in a different way. They have different transmission levels. Yeah, it's important for infrared. So we talked about fiber laser with 1070, 1080 nanometers, but we're producing as well green lasers, optical components, and we produce for UV. So we are spanning a wide range from deeper UV up to, I will say, 2 micron wavelength. So, and here we have to look into as well, not only for one wavelength. Next. What was very important and surprising was the homogeneity progression, the different materials, the different fused silicon materials. You see on the left side there is a cut of the fused silica rod material, raw material, and you see the different homogeneity cross section. And when we cut a red surface, when we cut the raw diameter for a lens element, you see you have different propagation over the diameter. And on the right side, you see the spot quality over the scan diagonal or over the image field. The red line is the optic axis, so on axis, and you see more or less a very constant optical quality, spot quality here. So when we go down, so the lens, the red circle, the lens raw material for a lens element, when we cut out on the close to the edge of the rod, you see the spot quality on the right hand is very, it's not very constant over the scan field or over the image field. You have big variation, and this ends up into a variation and quality variation on the spot. Next. So, and the next thing is very important for the high power applications as well. So the homogeneity was especially for the spot quality, but now we're going to the absorption of the material. And here we've made a lot of measurements, extensive measurements to qualify different, at the end we qualified 4 different fused silicon materials from 4 different manufacturers. And you see a very big variation, especially for the tidal laser or YAG laser wavelength, the first harmonic wavelength. So in between 1030, this laser, Trumpf, 1064, 1070, 1080, IPG, and so on. And you see there is material in the market, and this is a very common material used in the laser market or the optic market, which with a big variance of the absorption. But for us, again, it's very important to look on other wavelengths as well, because we produce and design lenses for green and for UV or for 450 nanometer and so on. And you see the the importance of the absorption, to know what the material, what absorption it has. It's very important, and we know this. We qualified this, we measured it, and we have a good overview about different materials. And at the end, we minimize thermal focus shift, and as always, a constant, stable quality over the field, over the scan field, and over the process over 24/7. Next slide. So how did we implement this into our key optic standard product? Key optic standard products for the laser material processing market are, for example, theta lenses and beam expanders. And so we have adapted our manufacturing processes to the new material, to the new selected material. We changed our working papers and so on, and the implementation of the new silicon material in 2019, we finished it. So all our standard products, off-the-shelf products, are now with this new silicon material, and this all has been done very price neutral. So for the customer, the price is always the same, and no changes in the price. And again, the material supply chain is secured. Next. We're doing further high power considerations at the optics. 2 points, 2 topics. We talked about coating. So we developed and we produced our coating by ourselves in Germany. And the influence of the absorption and of the thermal focus is coming from the bulk material we heard before, and it's coming as well from the coating. And so a very good low absorption coating is necessary. We develop such a coating, but we do not only say it's low absorption. Yeah, it's better that. And so we have an absorption measurement tool in-house to control, to monitor our serial production. So each low absorption coating batch is monitored and tested with this absorption measurement tool. And this is not only for the 1064 or 1070 nanometers, it is as well. We are doing this for our low absorption coating for green, for 532 nanometer. And before we start all the manufacturing processes, and we have a special simulation tool in-house, because our design tool is a self-made optical design software. So here we have the possibility to program, to adapt the interfaces between optical programs, optical design programs, and as well interfaces with FEM simulation programs. And here you can see just an overview. We have the possibility to simulate a thermal focus shift in a high power application. So this is especially for customized solutions. So we know the material, we know the absorption from the material, we know the absorption of the coating, and by simulation we can calculate thermal focus shift, and we can decide, for example, if it's really needed to have a water cooling system to cool down, or if it's to use a very good fused silica with low absorption, then maybe we do not need a water cooling system.
Thank you very much, Matthias. That was a really good presentation. I know your next slide, because I know your slide by heart. The next one is about the conclusion. I think that the story is very clear. We need to collaborate to actually bring those components to different systems. And I think one of the best system integrators we have in the room is AMS technology. So I'm going to give the floor directly to Torsten to tell us how we can actually do great system engineering with this component. Torsten, thank you very much for joining us. The floor on this Friday, 5:34 is yours.
Thank you.
So just hello to everybody. Can you hear me? Yeah.
Loud and clear.
Hello. So just a second to share the. No, here we are. Sorry. So yeah, in my talk, I want to talk a little bit about deflection and beam shaping for laser welding applications. For those who do not know AMS, I will say a few words on our company. AMS was founded as a distribution company in 1982 for electronics, optoelectronics, and thermal management products. In the last few years, we focused a lot on system on solution providing of subsystems for our customers, and especially in the photonics and the thermal management field. We have about 100 people European-wide, sales offices in Western Germany, and an optics design center in the UK, and an R&D center and some production in Poland. So for providing all these solutions, we have a global network of companies whom we are cooperating with their products and solutions. So one of the companies we are working with is the company NTT in Japan, and especially with their Advanced Technology Center, who is developing a lot of different products for internal usage, but also for external customers. Here in my talk today, I want to talk about two products. The one is Beam Shaper. In the different talks today, there was already some discussion on beam shaping and how you manage this. So the idea, what we have here, is to change the beam shape by a reflective beam shaper, as you can see here on the picture in the middle. So what you normally have is that you, by absorption, you get some heating in the transmissive beam shaper, leading to aberration and to focal point shift. So the idea is, like here on the right picture, that you have a reflective beam shaper, which can be water cooled on the backside of the device. So what our friends in Japan could do is they can handle substrates made of silicon carbide, silicon oxide, and so on which level depth structure is formed. You can see here on the right side a picture of how this device looks like. Of course, the maximum efficiency of such a device depends on the depth level. And of course, the device needs to be coated by a thin film to get a higher reflectivity. So what you can do here is, for instance, to have a gold layer on such a device, and you can reach about 97% reflectivity approximately, so that only 3% are absorbed in such a device. And the surface of the structure can be designed upon the customer's requests, like wavelengths. We heard today a little bit on different wavelengths which are used nowadays for all the beam welding applications. And it can be, of course, designed according to the designated focal depths and the m² of the incident beam. So here on this slide, you see a little one example, a beam shaper, which generates 26 by 26 spots. The beam shaper has a size itself of 23 by 32 millimeter. And it's used to generate a designated 25 by 25 square millimeter square, consisting of 26 by 26 spots with a 1 millimeter spacing between each of the spots in a distance of 350 millimeters. So you see here the beam quality in the focus, in the focal plane, and in front and behind the focal plane. So what is shown here in the 5 pictures below is only a 3 by 3 millimeter part of the whole square of 25 by 25 millimeter. So on this, that's it regarding the beam shaper. On this slide, on this page, I want to show you another device, which is maybe not that so good usable for beam welding because of the power handling of that device. It can be used for power up to, I would say, a few hundred watts. So applications are more like selective laser melding and things like that. So it's an all solid state beam deflector manufactured out of a crystal, which is called KTN, which is consisting of tantal niobate and oxide. The working principle of this device is that this crystal material, this KTN, shows a very large Kerr effect, which means that under an electric field, you reach a refractive index change in the material, and this electric field can be changed or modulated to get a different space discharge in such a crystal. And by changing this space discharge, you change the refractive index, which finally leads to a deflection of the incoming beam. And this device could be quite fast. It can run at an operation frequency of 10 kilohertz up to 100 kilohertz. And yeah, beam diameter is quite slow, but there are quite small, but there are developments ongoing to increase the beam diameter, which can be handled by such a device. And that's it, mainly what I wanted to show you today quite shortly. So now we are coming to the famous epic question. So what we can do is provide all solid state devices for beam shaping, but also for high beam deflection, for high-speed beam deflection. And what you can do for us is, of course, we are looking for partners to industrialize these devices. So we are looking for partners who are willing to test such devices. And
you're looking for partners to test those devices?
Yes. Really.
Oh, good. This is great, because we want to test these devices in Spain, right, Pablo? How can we test those devices at Ivan? Tell me.
Yes, I'm very, very curious about the solid state. Every time we hear 100 kilohertz, we get excited. We love to explore speeds, and we have some needs for very precise hitting with 100 watts could be a good power level.
Don't worry, Pablo. Don't worry. Just show us. We know what you want to tell us. Just take the slide, take the floor.
100 watts is suitable. This is experimentally proven.
Well, yes, I think Jose is giving me the
word, the floor, the attention of everyone, and all the power to keep us entertained.
Great, because something I have to 1 second. I'll try to share my screen. Yes. Something I can offer you. Can you see my screen, by the way? Yes?
Crystal clear, like you were next to me.
Great. Can you see my presentation, my pointer?
Yes, we can see it perfectly.
Yes,
Red,
excellent.
beautiful.
Something I will offer you from Ayman is the opportunity precisely of testing innovations in laser and photonic equipment for manufacturing. I want to start thanking EPIC for the opportunity to be part of this very interesting panel. And well, let me present myself. I'm Pablo Romero from my main technology center. We are located in the northwest of Spain, an area known for, well, manufacturing, technology, and food, as Jose mentioned, the greatest octopus and seafood in this part of the world, probably. And also, since we are growing and growing in European and international activity, more and more known for our labs, testing facilities, and the Laser Application Center, which is a special facility we have dedicated exclusively to laser applications with something, I don't know, I think we reached the 20 different type of laser sources mark right now, and all kind of robotic CNC and other types of equipment. But we have a broad range of offer. From the materials knowledge, we can, our expertise builds from the physical metallurgy and for welding and materials knowledge, and we build from there a knowledge on process monitoring, control, automation, robot vision, machine vision, and mechatronics. And we started with laser welding some 17 years ago with the first solid-state welding of PSA application. And from there, now we have all, you name it, from large scale, several square meter tape laying, laser assisted for aerospace, down to nano lithography, made by laser, 3D lithography with multiphoton polymerization. We cover all that. So we love laser welding. We love all the technical details that were mentioned now, but I was invited here to talk about something completely different. It's instead of ourselves developing as we normally do research and new applications, we want to offer our capabilities and the capabilities of the top research facilities in Europe to the companies willing to test new laser applications, especially SMEs. This is a project that was recently granted, Project Pulsate, which is a project on coordinating the research facilities in Europe to connect technology providers and technologies and make assessment experiment. Assessment in the way of not only assessing the technologies as they are fantastic and work very well according to simulations, things like those, but assessing also how well, how good it can be implemented in certain industrial environments like SME, manufacturing SMEs, and how they can be low stress implemented, and how they can fit in a digital manufacturing and Industry 4.0 environment, something that some of you previously, like Markus, for instance, from Precitec mentioned before. And we want to be that GPS that what he mentioned before, in the way that normally digital innovation hubs do this work of connecting SMEs to the digital single market through covering a number of digital competences. But normally, digital innovation hubs know a lot of about cybersecurity, about digital software deployment, things like those, but they have no knowledge really about laser technology and implementation in manufacturing. So we want to connect many digital innovation hubs in Europe and reach through them nearly all the SMEs and manufacturing companies in Europe, which could need laser manufacturing as an enabler, digital key enabling technology, but are not able to implement them because they don't have the capabilities to test in their environments. So we will connect IMEN themselves, also from Hofer, NTC, SINTEF, CEA, and the physics applications, laser application center in Vilnius. All of them high-level laser application and digital manufacturing centers in Europe, supported by EPIC. Also, they are partners with us. Funding Box, they are experts in mentoring and deployment of technology, and Glasgow, who is a company specialized in digitization of technologies. So on the basis of lots of previous experience and connecting to a lot of capabilities we have through actually connection to 74 digital innovation hubs in Europe, to networks and the pan-European ecosystem we are accessing. We want to offer, well, I don't have time in only a few minutes to explain how we will work after the project, but I can explain in 1 minute what we can offer during the first year of the project, which is opportunities to make funded, Europeanly funded, fast and simple test of laser equipment. So we offer our own test team facilities, our knowledge and our models of implementation to test the feasibility of testing of new equipment, like those you have been showing right now, like for instance, new laser sources, heads, test measurement devices, and so on, through two types of experiments. One is funded with up to 150 kilo euros lump sum, and the evaluation lasts only 2 months. It's a super fast evaluation, super straightforward. We ask only for a few pages, like 5 pages of text explaining what you want. And we offer not only that money and that possibility of testing, but also up to 4 months of testing in our facilities. And we offer also adopter use case experiments, which are economic feasibility studies and mentoring that allow the end user to be super reassured that the implementation will be effective in their environment. So starting next year, early spring next year, we will open our open calls, so you can apply for experiments, and we will be able to start experiments, which can be as short as a few months and as long as 1 year. Experiments which will start next summer 2021.
Fantastic. So you have 150K for any company who wants to solve a challenge, and they just can't work with you. They have two materials and they are like, I need to put these two materials together. They give it to you and you say, don't worry, I have 150K to solve that problem. And that's exactly what we want to hear. This is a big revolution. We're going to Precitec like crazy. And we're going to say, what is your challenge here? We solve it for 150K. You don't have to pay anything. Taxpayers like me and you are paying for that. Pablo, fantastic. Really, really. This is the kind of thing that revolutionized Europe. This is how we come together. Coming together always to solving the problems of the key companies who are building the machines in the key factories. And for that, I want to give the floor to LavaX. I want you to close the meeting strong. It's Friday, 5:54. Close strong. We want to go for a beer. It's Friday evening. The floor, Benjamin, is yours. Close it in style, as you know you can.
Thank you very much for the kind introduction. I assume you can hear me?
Loud and clear, like you were here next to me in Nordwijk.
Excellent, excellent. I am in my heart. So thank you very much for the kind introduction again. Thank you for having us here at the EPIC online technology meeting on laser beam welding. Let me first introduce myself. My name is Benjamin Gerhards. I am CTO of LavaX. And now let me present to you our company that is LavaX. We were founded nearly 2 years ago in 2018. And today we have customers from all over the world. We have 80% of our employees that are engineers, and half of them are international welding engineers. So you can see that we have quite big experience in laser beam welding, in special and in welding in general. Therefore, we see ourselves as providers for solutions for joining challenges. Our company is divided into 3 subparts that are consultation, manufacturing, and engineering. In the consultation department, we usually have customers that are not quite satisfied with the quality of their welds. Maybe you yourself know that because you are a specialist in laser welding. Sometimes customers come to us and say, the quality is not that good. And then we want them to send us their parts so that we can demonstrate the benefits of our technology right on their parts and show them what we can do with laser beam welding and vacuum. We can provide the whole chain of process development that does not only include laser beam welding itself, but also the mechanical and metallurgical analysis on a university level. The second area of expertise is the manufacturing area, where we take care of the whole manufacturing chain for our customers. So it doesn't really matter if you just want to have one part to be welded, one special part that might be in a very high price category, or if you want to weld thousands of parts within a few months of time, we can take care of that for you in terms of laser beam welding and laser beam welding and vacuum. So we are a partner for Job Shop as well. And then we have the third division, that is the engineering department, where we provide turnkey ready machines for our customers. And they are specialized for the needs of our customers. So it doesn't really matter if they want to have just one axis that is rigid and a scanning optics from above. If they want to have a universal chamber with 4 axes, including a rotary axis, or if they want to have a cycling machine with a rotary indexing table. So the amount of laser power are especially fitted to our customers' needs, which is usually less than 2 kilowatts of laser power. We also fit the vacuum technique to our customers' needs so that the evacuation times can be very low. And we also built our vacuum chambers to the needs of our customers so that they are fitted to the size of our customers' parts. But maybe we go a step back and look into what is laser beam welding and vacuum in general. Laser beam welding and vacuum combines the advantages of laser beam welding and electron beam welding, but without the drawbacks, if you will. When I draw your attention to the video that is displayed on the upper left, you can see a comparison of a weld that is conducted at ambient pressure and a weld that is conducted in vacuum. And those 2 welds are conducted with the same parameters. So you can see on the left side at ambient pressure, we have a plasma plume we have a large amount of spatters, and we have a huge molten pool and a huge dynamic in the process itself. If you look on the right side with the same parameters, we have no spatters, we have no plasma plume, and we have a significantly reduced molten pool. And the benefits of this is displayed in the right cross-section. So you can see with the same amount of laser power, we can achieve a much higher penetration depth. This is due to the fact that in vacuum, the evaporation temperature of materials is significantly reduced. We are talking about roughly 1000 centigrades for iron and aluminum. So we have the possibility to increase the penetration depth on the one hand, but this means on the other hand, we can reduce the laser power that we need to reach the same result for the weld. And this gives us a couple of benefits for our process. For example, we have an increasement of quality, so we have no cracks in weld seams, and this also applies for alloys that are difficult to weld, such as nickel-based alloys or aluminum-based alloys. And pores, on the other hand, are next to non-existent. We have the avoidance of spatters. So if we have spatters, they are so tiny that they don't adhere to the surface of the weld. We have the avoidance of vapor deposition on the surface, and we have nearly no oxidization, or we have no oxidization. This is very beneficial in terms of welding, for example, stainless steel for fuel cells. Furthermore, we have a very economic and ecologic product over here, because we can use low power laser sources. So as I mentioned before, our laser sources usually just go up to a power of 2 kilowatts, which is very beneficial for your for the money that you need to invest into our products. Furthermore, we do not need compressed air, and we have a significant reduction of the shielding gas consumption. And last but not least, what I want to say is here we have a very scalable process. So we can reach penetration depth from approximately 10 microns up to more than 100 millimeters. So we are in no way inferior to electron beam welding at this stage. So all benefits from laser beam welding and the benefits from electron beam welding with nearly no drawbacks, except for maybe the size of the vacuum chamber. The typical applications that we have next to welding of stainless steel, where we have very, very high qualities, and as well welding of titanium, are the typical materials that are used in the e-mobility, so copper and aluminum materials. You can see in the upper left picture, we welded copper foils with a thickness of roughly 65 microns, and this is possible with a laser power lower than 1 kilowatt. So as Michael from IPG said, we do not need any blue or green laser beam sources. We can do it with our IR lasers as well. And we can also reach penetration depth in copper of 6 millimeters, and we roughly needed 5 kilowatts of power for this. Furthermore, we have excellent qualities when welding aluminum alloys. Displayed in the lower left picture, you can see a weld in 7075 aluminum, and you won't find any cracks in those welds. As well, if you look at the welding surface displayed in the bottom of the picture, you can see that the surface resembles more welds that is conducted on stainless steel than on aluminum. We also conducted experiments on additively manufactured aluminum that is displayed in the upper right picture. You can see that over there. And usually you have the problem that there are many pores created because the material is very susceptible for the creation of pores in the weld seam. And as you can see, there are only pores on the fusion line on the right side, but no pores or nearly no pores in the weld seam itself. Maybe an outlook for our company at the moment is that we can also reach very high penetration depth. As I mentioned before, the possibilities go up to 100 millimeters and more. But it is not very beneficial to build a big vacuum chamber for those high penetration depth, because usually the parts that reach or need high penetration depth are quite huge in dimensions. Therefore, we created a mobile vacuum welding device that generates the vacuum just where it's needed and then through the around the welding where it takes place, and then it moves alongside the welding process. so we can reach the vacuum just where it's needed. And with 12 kilowatts of power, we reached a penetration depth of up to 40 millimeters, as you can see in the cross sections on the bottom. We also conducted some experiments for gas misalignments, or edge misalignments. So we had in the lower left cross section edge misalignment of 2 millimeters. You can see that there's a very high quality in this weld. And on the right side that's displayed, you can see we conducted experiments with gaps that went up to 1 millimeter, and we bridged those gaps by applying feeding wire for the process. So we are quite far in the process development and in the development of our machine. And at the moment, to say what we want to have from this epic meeting is we are always looking for companies to collaborate, for companies that are looking into new technologies, that want maybe to, that are maybe interested in what we can do with our technology. And also we always are looking into new technologies in terms of process, not manufacturing, process control and process sensoring, so that we can stay on the spearhead of technology where we are at the moment. So thank you very much for your attention.
Thank you so much. It's been so great to have this as a closing, when we have everything put together and then you have the station to actually combine. For me, these kind of meetings are great because all of you are really gonna connect. I actually took a lot of notes today. We talk a lot about laser beam monitoring and the need for coatings for the beam monitoring. We talk about the laser beam welding into different materials, and that for me is like the biggest challenge. And we talk about aligning the beam as perhaps something to talk with the automation for manufacturing machines. We talk also a lot about laser heads. I love the presentation from Precitec. Markus, you were the star today. If I had to give an award, it would go to you. I think there are a lot of room for collaboration, especially adding new imaging technologies. And they are NIT from Madrid, actually. They have something that collaborating with you would actually benefit both sides. Laser optics are still always the coolest part that we have on Epic. I think we have the best laser optics in the world now in our community. So any challenge could be actually addressed. High power FPGs, we really love the presentations from Civan, also the comments from iXblue. A combination of different colors is something that we didn't address enough, and I think there is a lot of room for collaboration there. The power supply were addressed by PVF. The prototyping, I want to remind this, Pablo has a lot of money from this industry and he's willing to give it to us. So any challenge, go to him. We're going to do something fantastic with this new initiative called Pulsate and the beam shaping. I love the presentation from Civan. It's fantastic what you can do with the special light modulators out of this world. I really try to summarize the most important part, but the most important part is this. If you want to contact any of the participants today, because now the ball is in your court, I'm going to have a fantastic weekend. If you want to contact any of the participants today, all you have to do is send me an email, jose.pozo@epic-asoc.com, and I will introduce you. I love doing that. It looks like a lot of work, but it's not. I have my tricks. So please send me an email with any company that you want to contact to have a fantastic follow-up. I would like to say on behalf of fantastic Francesca, who was fantastic today, and the rest of you, have a fantastic weekend. You deserve it. You work hard. It's 6:07. I apologize for the 37 minutes I took from you. I will find you business to pay for that. Take care. Markus, I like you so much. Precitec rules. Take care. Bye-bye. See you.
Bye-bye.
Bye.
Stay connected or ask us.
Bye.
Bye.
Happy weekend.
Bye.
Bye.
Bye, Gwen. Thank you. Thanks, everyone.
Bye-bye.
Hi, thank you. Maria, you didn't have a chance to speak. You need to join another one to have something. I didn't see you. But next time.
Jose, we will follow you on the 24th.
Please do. 24 hours awake. You can do it. Matthias will follow as well. I will send you coffee to all of you. Thank you, Torsten.